1, 2, 3, 1, 2, 3, 1, 2, 3.
Здравствуйте, коллеги. А вопрос техническая служба сейчас кто-нибудь присутствует?
Да, мы тут.
А я не вижу, чтобы запись собрания велась. Вот здесь.
Скажите, мы начинаем?
А вот она. Но она зашла как, смотрите, пользователь. Ее, наверное, надо сделать организатором. Ну,
Светлана Прокопчина?
Да.
Все сделал.
Здравствуйте, коллеги, вы меня слышите?
Да, слышу.
Good afternoon, colleagues. Can you hear me? Yes, I can. You've turned out your mic just now. Now we don't hear you. Now you can hear me, right? Yes, we can. So I think. So shall we wait for 5 more minutes because we have a lot of participants, or shall we start, or what? What do you think, Yuri? Maybe we shall wait for some 5 minutes. Yes, let's wait. Maybe 2 minutes more, because I see we have few participants at the section, and I do not see the next reporters. I do not see Mr. Aversky, Yarushev, Avinov. Just 3 minutes more to start in a calm manner. Okay, let's do it.
Николай, вы здесь?
Nikolai, are you here?
Да, Юлия Александровна.
Yes, I'm here, Yuri. Please make Zhukov a co-moderator. He will help us out. Done it. Thank you. So
Да, верно.
the recording is on. Yeah, probably.
Коллеги, я пока...
Colleagues, I will remind you, there was a request
Встроенные микрофоны, если...
to speak not in the inbuilt microphone, but to try to find a special set with a mic so that there would be any hindrances from the room, because the mic will be closer to the mouth and the sound will be much better. And also request when reports will start, if you have any questions, just raise your hands. Because there's an option here to raise a hand. There was a button to this effect. I cannot see it now. Yuri. And we should take into account that 20 minutes for a report together with questions. And the colleagues should take it into account, yeah. 20 minutes for the report, including the Q&A. So the report, the presentation should be 15 minutes. Sorry for interrupting, Yuri. If our colleagues want to ask their questions, then 5 minutes should be reserved for the questions, for the Q&A, because the organizers asked us to keep the time very tightly, because many people will join in for the time, because some people from other sections want to hear to our presentations. That is why just keep the timing, and if the questions are needed, then you're welcome. If you can do it on a chat offline, then it's another option. So I think that it will be 5 minutes in a minute. And another request, those who do not speak, just switch off your mics so that we would be able to listen only to the speakers so that no other sounds would distract us. Okay, let's take it into account. That's a correct remark. So I think
Я думаю, что, в общем, можно начать, наверное, да, Юрий Александрович?
we can start, Yuri. Yeah, probably yes. We can start. I think that I mainly see we have the speakers already. I think that mainly everybody will hook up. Today's section is dedicated to very important issues. They may seem classical, but nevertheless, as of today, it plays a very important role in creating new technologies like data science and big data. And we hear it all like data mining, etc. Everything relating to IE, artificial intelligence, and the idea behind this section will be focused on this trend between the artificial intelligence and the classical theories of modeling, measuring, and applied tasks. That is why virtually all the reports relate to this issue. And one of the main aspects, among other things, is modeling and the work of algorithms and technologies under the conditions of uncertainty. So that kind of topic allows us to look into a wide range of issues and tasks on our section. It's a long section, a lot of reporters, and if you have questions, certainly we will have questions. And I would like to thank our speakers for participation in the section, and I hope that they will later on take part in developing these issues relating to the intellectualization and the application of the newest trends in measurement and management. What else I would like to say is that the section is being reported, is being taped, and it's on YouTube, it's on air now, and also there will be a publication. We want to publish it in special journal, Economics and Management, which is an information partner of the conference. And if somebody has a wish to publish a full-fledged article, please contact the organizers and they will help you in this respect. To keep the time, because we see the participants, probably we should start. We're trying to start the presentations according to the program. The first presentation is my presentation. That's why I'm trying to switch on the demonstration. Yeah, colleagues. Colleagues, I haven't told you. If you are a presenter and showing your presentation, the best thing is to give access to all the working table. It's the easiest and the most reliable solution. I beg your pardon. Now we launch PowerPoint, the presentation. Can you hear me? Yes, we can hear and see you. Okay, then we get to the presentation. Beg your pardon. Yes, show the slides. It's the button. Show the slide. Just a minute. Just a minute. And can you raise it somehow? Beg your pardon. I was closing this bookmark. Now we can see.
Да, все хорошо.
it.
Да,
Well,
все.
yes, very well. So my presentation is a little bit different from what was in the program, but please believe me, this is virtually what I would like to tell you in the previous title. So we'll be talking about a comparison of classical and generalized measurement theory. Today's tasks, as they are solved now, and which methods could be used, and how the measurement technologies use algorithms and systems, together with what is needed by practice and which tasks we should look into and deal with and solve them. Because systems measurements and singular measurements is not the generally used terms, though it has been underway for a long time since the late 90s, but they haven't reached state standards, but the definitions are here. And to make my presentation clear in terms in which way we will make these comparisons, take a look at the definitions. Singular measurements is measurement of one physical parameter in the conditions, definite conditions of experiment with attributes of measurements that object and signal, which is a model one, scales of relationship, uh, digital benchmarks, and a simple
Схема
scheme of comparison, where we mean a comparison between the two measurements and
объект измерения
the lack
даты
of
на
any impact of the environment.
системные измерения. Это измерение
Systems measurements, those are measurements whose objects are complex physical and non-physical objects, system functioning in the conditions of informational insecurity and actively cooperating with the environment, which uh, so the comparison will take place according to the concepts. And in the classical theory, measurement theory, the object of measurement is a physical parameter. It's always accessible for direct measure. The specimen object is a physical parameter. Scheme of comparison is the simple algebraic of two numbers, and tip measurement scales is the scale of relationship scale. Benchmarks, digital notions, and Euclidean matrix. The equation is like the classical measurement, some optimum which is closer and the distance is chosen beforehand, and we compare the notions where the closest benchmark is age as a result of is limited by the range of measurement and belongs to the experimental notions. But what happens when the system is an object of measurement? Then a lot of factors impact it. When the processes change in time and so fast that the result of measurement should be acquired given all the impacts and also small samples relating to the object or unique phenomena. Very often you can see it in the physical task and social, economic, and technical tasks today. That is why the approach relating to the conditions of measurement is poorly applied here. And the concept and the scheme of measurement in the generalized measurement theory is as follows, or let's propose the object of measurement is a complex object inaccessible for direct measurement. For example, the plumbing network state or the state of development of some industry. As a rule, it's complicated structures where there are some local subsystems actively impacting and changing depending upon the environment. A specimen object models could be a
объект
similar or a virtual object,
состояние
as an ideal state that we should compare something with it. As a rule, those the comparison schemes, they are not usual equations that could be realized in one click, but information technologies of solution, not algorithm, but technology of solution, of resolving. And the type of this technology mathematically is a reverse task of image recognition. And those are benchmarks on special scales. And we'll be speaking about that later. And the images could be the situations and the states or some complicated features or integral indicators and types of benchmarks could be figures or linguistic variables or assessment or graphical video or audio information cartography, etc. The type of measurement scales, those are special scales with dynamic limitations, and I will show you just a little later. And in the equation of measurement at the same time there appears some specific features. And please know that in the left hand side it's not one measure but a totality of H measurements which are related to and supported by a complex of meteorological characteristics. And I will tell you about that in detail because this is a very important part of the metrology of the measurement. So the equation has this looks like that. C could be different, like bias, that I very often make reports about, presentations about. A phi function is the functional transformation on the scales, looking for the optimal solution of the multi-alternative in this part of the equation. And f is the functional transformation that could be made on with the whole complex of x values. And some indices should be added, I beg your pardon, as I've said. So x of those are information flows which should be processed. But given y, it's being this a priori information we use it for the measurement, meteorological requirements for limitations directly involved, included, and certain indicators of the quality of measurement. Or I beg your pardon, certain limitations from the environment factors. This is the scale which I've been telling you about, which is a double link scale relating in the vertical and horizontal axis. On the first scale, there are digital values, and within this, they are, and that is why I haven't told you that there could be Kullback's measure used, and here this is Euclidean, but on the bottom is a combined linguistic scale with different magnitudes, and they are on top of the norms, above the norm, yellow marks which says that, and criterial scale, because the terms here are the degree of manifestation of some quality in line with some criteria, like in manufacturing could be maximum permissible concentration or some emission or some standards. On the left hand, you see multi-tier hierarchical model, which represents the object, the complicated object. And here we speak about the state of the boiler room. The main principles of the methodology are given in this slide, and I will read it and make some comments. Implementation of measurements within the framework of unified regularized space, because and if we do not regularize, then the task will not be in line with the three conditions of Adamar. three conditions of Adam are existence of solution, the only solution, and the stability of solution. And if we do regularization and we use it by multi-measurement scales, then those conditions are conditionally met. And for each parameter, within the integral restoring the values, then metrological maintenance as the reliability, risk, information, which are a must, should be along with each step. Changing the conditions is one of the main aspects which allows to use additional information and to get adequate solutions in ever-changing environment. Get adequate, uh, providing for the development ability of the methods and models, because if the object is changed, then the models should change and the measurement technology should change, and it should be correlated very closely with the conditions, the cognitiveness and interpretation, because it's a very complicated task, multi-stage task, and it needs, and today it's one of the interpretation and the measure.
Because oftentimes such measurements included to the complex of the monitoring of the audit, because this is supposed to be seen at every stage what results are being obtained and what is the state of presence. If you look at the previous slides, we'll see that the violet is critically above the norm, blue exceeding the norm, critical is exceeding the norm. In the same manner, we use other colors, which will be shown further, and also the audit is being conducted, how well and how not well measurement is being done and being identified. Opportunity to use the wrap up of the numbers, extremely important moment, especially in the concept of big data. The scale can be done on multiple levels. Let's say from the scale of 28,000 factors, you can go to one measurement scale and measurement of the object at the one measurement scale. Vice measurement, use bias wrap. I also have 3 minutes. That is why I'll try to, and yes, the most important conventional state. I'll try to tell you the several slides that reflect the specifics of the object of the measurement. First of all, it's made of the number of the subsystems, and subsystems can be relatively autonomous, but entering this super system that, according to Mengent law, possesses unique qualities not typical for the components. Technology should be oriented at the measuring separate features of subsystem as for the management of the Mengents. Further subjective component of the measurement process of the system measurement is extremely important. Its inclusion of the measurer and the subject that carries the knowledge, number of the sources of information, and metrology orients at it. And further, subject can be receiver of information, so it's a separate direction and separate specifics of system measurements. I will not list specifics of all of the generalized objects of measurement. In detail, you can look at the presentation and the use dynamic model, conceptual model of the external environment, and the synthesis of the models. We offer a model of the object of the system measurement with consideration of the condition of measurement. The most important is metrology of the system measurements. Here, I suggest new results, and I'll briefly explain. And I show that classical measurements that have uncertainty we consider information according to Fisher, it leads to, under the dependence factors, classical measurements can be listed down as the list of characteristics according to the equation 6 and transformed errors that are typical for results. But when we accept results of system measurement, the most important is the change of the structure of this formula, because because of the enthalpy and emergent characteristics will have such result. I'll briefly explain the resume. In this case, adding of new knowledge and data that has to do with external environment and condition of measurement, as we saw in the equation of measurement, can increase precision and information content, and can also decrease. Without metrology of these flows, without metrology of the solutions at every stage, practically there is no opportunity to create effective technology that would achieve the requirements, because this is truly existing, and we suggest a complex of the metrological characteristics realized in technology of bias, of soft cognitive measurements, and so on. This is precision, this is reliability of level of the first and second type of errors, such as the wrong solution, reliability of solution, its risk of solution, risk of usage of incorrect solution, number of the amount of the new information, and the level of entropy, how much decrease of level of entropy and what new information being gained. I'll give you example very quickly. We worked with the banks. They have 135 features. We selected 32 and we started to check those by such measurements. It happened that practically very few, about 10 indicators, have informative value. The others were related, didn't carry information. And the value in such way, decrease of the number of the indicators can be achieved as example of such networks where measurement is being done. This is now your information system related to the Internet of Things. As you see the pictures in the bottom, all information is being from video cameras undergo treatment. Colleagues, thank you very much, and I hope that maybe I was clear, maybe I was not clear. I'll wait for your questions and any observations, and I'll be appreciative of this. Yes, Svetlana Vasilyevna, thank you. You reported 15 minutes. My last question, you said there is example of measurement that worsen information. Can you explain? Worsen.
Есть такое.
There is, unfortunately, I out of presentation. The essence is that the scale, if you remember, the scale that I was showing, in essence, is the distribution law of probability. They clearly wash out. In the text it says they worsen. We can gain knowledge.
Размытые.
Very washed out, blurred, unclear, contradictory, under condition of uncertainty of big flows, characteristic situation, and then adding such knowledge without metrology, without determination of quality, we blur distribution law. It becomes less certain. It's sort of the distribution law blurs of the benchmarks, and we cannot find optimal solution because it happens that we have big inflow of entropy properties in this case. That's why such knowledge and such assessment of the expert cannot be used directly, and you should clear by gaining quality. You asked for perfect question in the system measurement. I didn't say it. Not metrological attestation is important, like for the classical measurements. So the error is so much according to the normal law. It's not here. More important metrological synthesis that is in order to gain final result, and from it goes reverse chain of meteorological grounding, and such flows of which I spoke, blurring, are not allowed or subject to additional treatment. Thank you. If I answered, I hope. Yes, thank you. This is example such in the selection you add observation deviating from the selection the average value, its extreme peaks. You should check whether they are real or they are random according to the special algorithm of processing of extreme values. Colleagues, any more questions from you? If you have no questions, I'll ask another question. At the very beginning, there was a formula art minimum and then function f. That was phi and f. Phi and f. First was f, is treatment of analytical data, and the value x, information flow. For instance, indirect measurement would take some value that we gained subject to treatment. It's a family of functions that work on these flows, and phi is scaling. It's gaining according to the rules of system measurements with certain value of benchmark or the combination of benchmarks. I hope I answered your question. Yes, you answered. Yes, it's clear. Okay, I understand. C is bias C criteria.
Спасибо.
Yes, thank you. If I have no more questions, let's switch to the next presentation. Yes, let's switch to the next presentation.
Yeah, I see on the next one. Maybe they will come later, and at the end we will be able to listen to them if we have time. And now we have a presentation with Alexander Tuskin, development of methods of identification of the best available technologies. But I was prohibited to switch on video. Hello? But without video, but you will be able to present your report. Alexander, you have the right and a request. You have a window to include, to switch on the video. I asked for it twice. Yes, I have it. Just a minute, please.
Сейчас есть?
Now, do you have it? Yes, we can see you, but we do not see the presentation.
Так, я его вижу.
I can see it.
Надо нажать кнопочку
You
демонстрации.
should press the button screen demonstration. Yes, I'm pressing. And you select the screen as the first thing to do.
Вот что-то грузится. Вот
Something is being loaded. Now it has loaded. We see the presentation. We see the first slide. I will make it a little bit full screen. It's okay now. Everything is okay. The development of methods of identification of the best available technologies. It relates to the problems of implementation of the strategy of sustainable development, which today is probably one of the priorities in scientific research, and one of the main principles of that strategy is the rational use of natural resources. On the environment, and negative impact is made by the industrial enterprises. In full scale, it is impossible to exclude it, but it could be minimized due to rational methods of regulation of environmental protection that would promote the development of innovational green technologies, so-called green technologies, and the modern principle, the basic principle of ecological regulation. Some problems. Stimulates the application of the best available technologies as the basis for the solution of the environmental problems and other ecological permissions. To the best available technologies, we have the efficient technologies in the corresponding sector of industry, which provides for the highest possible level of environmental protection and which have reached a level allowing their practical implementation. And the idea to use the best technologies is that for the active manufacturing enterprises, the permissible emission levels and waste removal should be set on the basis of the best technologies in this sector, best available technologies. In the list of those technologies, there are permissible impacts. You can find it in special reference books. This idea is being implemented at the start of this current century in the Western countries, and recently the main principle of main principle of regulation in this country. However, the problem is that the best technologies, several technologies want to be proved as the best, and the comparison of those technologies that do not have obvious advantages. This is quite a complicated systems task, which should be taken into account. A lot of criteria should be taken into account of different kinds of impacts, environmental impacts, expert assessments of all local problems, and choosing the best available technology is quite a complicated task, and goes without saying that here some formal instruments, tools should help, and the development and improvement of those tools is a very important task still. And there's a big number of publications to this effect, but virtually in all of them, the approach is that what is being compared is the set of alternative technologies with the use of the methodology of taking decision making and the selection of the only technology out of the range of technologies, but the concept itself of the ecological regulation uh, doesn't make it necessary to use a certain technology, but envisages setting the extreme values of discharges of the emissions on the basis of those best available technologies. That is why the rational determination uh, of a kind of the best combination of different technologies without using only one technology, it could be efficient, economically wise. And we propose a new model of the mathematical programming, which allows, due to the combination of different technologies, to minimize the operational costs of an enterprise with due regard for the ecological requirements. And so the task setting is that there is some NVT, certainly which determines the permissible levels of emissions, but at several stages of technological process, some alternative options of operations are possible, and such kind of a situation is illustrated by this figure. At the stage G, there are three alternative operations which differ in their negative impact on the environment and the operational costs. For example, when preparing the surface before applying galvanic coatings, it's possible to use electrolytical or chemical processes. And in this case, these processes can have several options of implementation. So the scheme of technological process could be seen as an oriented graph which has to do with certain operations. And the task is to choose the optimal route or a set of operations that would completely provide for all the stages of the technological process, or which are the operations with the minimum costs and the total emission levels that would not be higher the permissible level. At the same time, it is necessary to fulfill some technical and economical limitations. Economical in terms of investment to create a technology, and as for being in line with the ecological norms is a must for the selection of technology. So we build a model where we test the parameters. So the scheme of the process includes several stages for each of the operations, which include all the alternative technologies. A parameter is set that determines the operation and attributed to a certain stage. For the selection, technological and economical criteria are taken into account, and technical criteria, and for each emission, discharges, waste, etc. Not necessarily emission, maybe wastes. The maximum values are given of the total emissions throughout the whole technological process. Also given is the volume of the maximum investment resources as the maximum value of some technical parameter for the whole process. For each operation, we give the operation costs and maintenance, the level of emission for each operation, and capital costs for the operation, and the technical parameters. As for the technical parameters, different options are possible, which determine the requirements in terms of the service cycle, and we use only one parameter to simplify things. The surface occupied by the equipment and the value that we're looking for. It's the goals parameter which determines the inclusion of each operation into the technological process or not. The parameters of technological processes cannot be given unequivocally, and the reference books determine the ranges of information for determining the parameters. It's determined by the existing manufacturing processes and documentation of the developments and other reference books. And there is no unequivocal parameter, value for each parameter. It develops the productivity. To choose the technology and the parameters of costs and the emission levels and the technological parameters we present them adequately. So the model eventually could be presented as the mathematical task for programming with unclear parameters. The target function minimizes the total operational costs of operation that we include in the combined technological process with due regard for the limitations in terms of the maximum emission investment and the task is limitation of including only one option of operation at each stage of the technological process. The results used from this model we show on the demonstrational example, choosing an operation of a technological process, preparing the protective coating and applying it. We give the stages of this galvanic technological process. And on the next graph, we show the technological process with the basic technology appropriate. And in gray, we show the operations, but for certain operations, alternative options are possible. And they're represented in punctured lines. The parameters of the operations.
For simplification purpose, we use only technological limitations such as emissions and the drainage. Each parameter is set by unclear number with the appropriation. Some simplification, but the triangle, they reflect uncertainty of information and happen to be convenient for computer realization of the processes for solving this model. As the result for this task, we determine technological process that provides minimum of the operational cost. On the left is basic process, and this is optimal technological process whereby selected at some stages other operations and comparison with the basic process at the value of emission and operational cost shows that we gain rather big benefit with the program of 30,000 square meters of the space, the average value for the plant compared to the base variant. We gain decrease of the operational costs by 5,250,000 rubles, which in fact is quite a good saving. And this is the odd number. We gain a lesser value of emissions. So we fit into the limitations and decrease the number of the emissions. And the gain results we can consider as the expansion of the instrumental mathematical vehicles using the best available technology that allows enterprises to justify solutions in ecological and economical sense. And for this task, in principle, it is possible to expand, broaden the model through consideration of additional limitations, such as technical, economical characteristics. We can expand model considering different social, political, rather complex criterion. But in any case, the both model provides quite sensible advantage while selecting the best available technology at the level of decision making. Thank you for your attention.
Да, спасибо.
Yes, thank you. Please don't close presentation because I have questions regarding these frames. Please explain what is emission of technological process. Emission of certain operation, we can say technological process. Some evaporation takes place during etching different bad substances. They emit into the air, emit into the water, but emission into the air and the drainage is also called emission. It's negative flows that affect environment. So it can be electromagnetic radiation. Emission means, in essence, the level of pollution, the flow of pollution from given operation. Yes, from given operation. Can you go back to the slide with optimization task?
Вот.
Параметры или модель?
Вот мне сама модель
Parameters
интересует.
of the model. I'm interested in the model. It's minimization of the level of pollution or minimization, the cost minimized for realization of the operation, while observing all ecological limitations where we add limitation, technical limitations. This new technology that we realize in our plant should fit into the existing space. We should consider that we have limitations in terms of money for realization of such technology and compulsory correspondence of all limitations regulating logical size of technological process. The most important out of this potential, not the most important, but the criteria, this minimization of the operational costs. This task is solved at the level of an enterprise. The best available technology means that the reference book for the sector of industry and possible solutions, technological solutions. The idea is, out of solutions, you can select a combination for concrete enterprise that would allow to decrease operational costs.
Да, спасибо, понятно.
Yes, thank you, understand.
Просто как бы
I sort of have observation, not to your work, but in
это
general.
то, что
It happens that the care for environment protection
в системе ограничений,
always seen in the system of limitations. Is it possible to do
как бы
in reverse order
минимизировались, чтобы они
to minimize emissions so they become target function and limitations would be
финансовые затраты,
financial costs,
прибыль ожидаемая. В общем,
expected profits?
наоборот, как
Can you flip the task?
реализовать.
Can you realize this? This principle itself of logical regulation, which is being used today, it determines that all these emissions of functioning operational enterprise, such as emissions and drainage, should not exceed what is determined by the levels that are applied by the best available technologies. That is, you cannot make up anything better out of what is known for a long time in the sector of the industry. It can be one set of processes, can be another set of processes. To this problem, the level of DT, you have to select such technologies that provide minimal emissions. This is also very complex because there are many emissions, and objective is But if the reference book determines a set of the best available technologies that can be used, it is believed that today is reasonable effect on environment. And we at the level of an enterprise or at the level of device, we should not exceed these critical values of emission. But we for ourselves trying to optimize from the standpoint of costs. This is the essence of the task. In principle, at the level of selection of technology, at the level of industry, your approach is quite fair. And the problem is being solved like this. It is believed that you have to minimize this ecological impact with some reasonable costs in order to implement these processes. They are called best available technologies. Availability determines that you can buy them somewhere today, and they're relatively accessible from the standpoint of finances. An enterprise should not bankrupt by purchasing this or that new technology. Yes, thank you very much. Colleagues, do you have any more questions? I think, Yuri Alexandrovich, you should switch to the next presentation so we have better picture and the questions can be asked offline.
So time with some problems with time. Let's move to the next presentation. Next presenter, Alexei Gubernatorov and Mrs. Alexandrova, Irina Alexandrovna from Vladimir, about the application of modeling in management, financing the waste management of solid waste. Please repeat, who is the next presenter? Alexei Gubernatorov and colleagues. So we are colleagues. Somehow I don't see the video. Okay. Thank you very much for allowing me. Let me thank the participants and all the presenters and the organizers for the chance to speak. Several times we participated offline in your conference organized by the Financial University. We have a lot of gratitude working for the conference. About the subject of our presentation, it's a practical one. It's related to the previous presentation with the ecological problems and the issues of environmental protection and managing household waste. And the results of our research and the presentation was tested and approved by the grant from Russian Fund of Direct Investment. And so the application of modeling in waste management, household waste. Everybody knows that household wastes are the wastes and goods that are no longer used by people in the housing to satisfy their own needs, and the similar ways in the process of economical entities like household and communal waste, solid waste. In January 2019 reform kicked in, which approved the new reform of handling waste management everywhere in Russia and caused a lot of changes and issues in the existing system. That is why looking into this problem and all the aspects in terms of the systems analysis and in terms of some alternative tasks is important. So the new reform of managing the household waste presupposes the tasks relating to the accumulation and transportation of waste, detoxification, and utilization. The complex technological chain that we can see on the slide. Today, the chain of waste management in Russian economy and Russian Federation is built on the basis of the Lansing ladder, which reflects the hierarchy of technological methods of treatment. In terms of diminishing priority, we can see on the slide that the Lansing ladder presupposes the technological processes and stages of waste management within a hierarchical stage. So burying at the bottom, then burning, with and without generation of energy, composting, treatment, reusing, and prevention. And it makes sense to say that in Russia, we mainly use the technological stages that are on the lower level, that is burning, and at the same time, the share of this waste is up to 80% compared to foreign countries. The burying, like in Germany and Sweden, the burying is 0. In Netherlands, Belgium, it's 1 to 5% is processed. 1 to 5% goes to transformation, processing, waste treatment, and up to 32% goes to recycling. Certainly, this problem wouldn't have a reason if, as it was in the past, within the waste we would have organic mainly, and it was not a very big problem for the environment, with the exception of the west part. And when the morphological composition changed of the solid communal waste, so the share of non-organic increased. So we had to move to higher levels of treatment within the system. We should say that certainly both the states and the regions and certain municipalities and enterprises, they resolve the issues of modeling the system of managing the waste, and all those solutions are within the reform that determines the strategy of waste management in Russia and the federal law about the waste and the national project ecology, which sets the benchmarks, the complex values that we should reach to successfully solve this problem. On the slide, to make use of the modeling processes and to use different models, we have taken a trivial on the one side, on the other hand, this is zero model that allows us to cascade a lot of elements within the system. On the slide, we see the context diagram of funding the system of waste management. At the intake, we have the solid waste, the rates for collection, the tariffs, and if the state takes part, this is the targeted funding. and the own funds of enterprises. On the top, we see the management, on the basis of which institutional foundations, of which ecosystem this is built. The national project, the federal law, strategies, different levels of strategies, and on the bottom is support from the population, the Ministry of Construction, emergency ministry, and some other organizations who are related to putting together tariffs and regulation and supervision. So this is a universal methodology that could be applied for different systems, not only waste management. It is also used for new to determine main requirements and functions. For example, all the technological chain of waste management, we presented it. And within the first level of the composition, we presented it within the framework of the following context blocks: is accumulation, transportation, treatment, detoxification, and burying in landfills. And at each stage, we offered our own levers and financial tools to fund the activities. For example, at the stage of accumulation, this is the collection of waste for their treatment, and subsidies and investment of enterprises go mainly to manufacturing of containers to collect rubbish. At the stage of transportation, which is the process of moving the waste by specialized companies, regional operators do the transportation, subsidies and investment and own funds go to the transportation by special vehicles. And at the technological stage of treatment, we do the preparation of waste at specialized enterprises for the further utilization, including sorting out and cleansing. The regional operators sign contracts with the factories and other operators who do some process. And the investment and own funds at this phase, as well as at the detoxification and utilization phase, go to the sorting and treatment of solid waste, and go to development of modern purifying equipment. And after the treatment, the waste could be used for utilization and for landfilling. And this is decomposition of the context diagram. We can see it on the slide. And the last is the detoxification of waste, includes the process of changing the composition, the features, decreasing the mass by burning, among other things. Subsidies and investment at this stage go to burying in landfills and to provide for the safe burying in landfills, and to the recuperation of the old landfills. And this is a decomposition of the second level of burying in landfills of the solid household waste. Why have we chosen this technology? Because first of all, we can do the functional and cost analysis, identify the business processes which are more important, or the business processes which are less important, to do the re-engineering of the business processes, to do the functional and cost analysis, to calculate the costs for the function and costs for the time of the implementation of the business processes, to identify the business processes which are complicated or are in combination with others. And these values, these indicators, they are different certainly from the indicators which we're used to analyze within the analyzing the financial activities of an enterprise. So these they are universal, general purpose for the technological of EDS. But the dilemma is what to choose and what to fund. And for the further research to go on successful, we continue developing. Our next stage was identifying the factors impacting the choosing of the model of funding and we did the research and we found that 125 factors impacting the choice, either your own sources and funding or some debt sources. Then we put together in groups all the known technologies within the model of funding, and we had 7 of them, like mixed funding model, the funding model based on the private public partnership, concession agreement model, and their variants of them. To identify which of the 25 factors are more or less impactful on choosing the model of funding the waste management, which shows the toolbox and the expert method of assessment or the taxes methodology, which also allowed us to determine the most important factors and which model, whether it's good or bad or universal, all the time we need some support, institutional support, and the support as the support in each region would like to create ecological techno parks. This was to manage the solid communal waste. This is bringing together material and raw materials balance and the links, including buildings, technological equipment that is used in the treatment, utilization, detoxification of waste, and certainly the range of the research and educational activities, because on the sector level and organization level, without R&D, without research and development, the real sector is unable to exist. That's what we think. And just in a nutshell, I gave you the main results of our ongoing research. Thank you, the colleagues. I'm ready to answer your questions.
Спасибо. Ну вот вопрос получается, что
And so the question,
модель
so your model
финансирования
is the model of funding of a system of waste management of solid waste.
финансирования.
And who does the funding? Once again, what are the sources of the funding? Well, the participants are the people through tariffs, and if there is some external support, it's some debt sources or some are their own sources. Those are the tariffs for the management of the maybe the payment of the users of the secondary raw materials, or some additional sources like subsidies or some leasing funding and debt funding. So we put them together in groups, all the fund sources, and we divided them in our own funds, additional funds, and debt funds. And once again, the slide where the funding starts, the context diagram, right? Context diagram.
Пожалуйста. Контекстная
You're
диаграмма.
welcome. Context diagram. So here we have collection, transportation, treatment, and it shows the transportation of waste in and out, going in and out. Support meaning the strategies And who is the regulator? Who is the decision maker? And who cooperates? The management company or the company, leasing companies, credit companies, transnational corporations can take part, like VEB Bank. So all the participants now are interrelated and have both direct and indirect impact on the system of the household waste. And that is the most difficult thing, to look at how the things are today, because the reform is undergoing, and not in each region this reform has started even, especially in the regions. So like in the Vladimir region, we only put together and test the technological suits, the roadmaps, how this reform, not only funding the system of management, but the management of this, because how can we speak about the funding if there is no technological maps and it's not clear who is responsible? And we tried with the help of this research, not only to look what's happening on the top, but to decompose this model and to get down to lower level. But the model has been tested successfully and gives us such a possibility. And the question, maybe it's not about your report, but it so happens that everything is paid for by the consumer, but at the same time, the payment system is linked like a monthly payment or per square meters of dwelling linked with the human beings. But at the same time, we don't have such a thing that the cost of utilization would be included into the price. Like, for example, somebody bought a dozen of TVs and then he immediately threw it out. And another guy just bought one TV in 10 years. And the cost per person or per square meters is regulated, but it doesn't include who pays for what he had bought. Is it possible to implement such a system? A good question. We haven't thought about that yet, because we were trying to implement this model within the legal framework, and we tried to enlarge our regulation and to inscribe our model into it as an innovation method to hand over the responsibility to the end user, to hand such costs on the end user. I think, well, it makes sense. I think we can look into that as one of the factors. Why not? Okay, thank you. Can you show, just go through the diagrams with models? There was something interesting for me, but I cannot recall the slide exactly.
Question was like this: look, it is supposed where the treatment is, there must be some treatment center that process the product near the producer. Every producer can use absolutely free selected technologies and can be like this. In some processing center, there is no support opportunity of processing the products manufactured according to the certain technology. Once again, maybe it's reasonable to give processing to the producers. For instance, to oblige every producer to recycle their own merchandise. What do you think? Can this happen or not? It seems that at the federal center, I understand the question, it's rather, it already exists. But if it's carried out at the regional level, because waste treatment, waste burning that is done haven't reached the regions, I think it's a little bit of expensive for the goods producers. I mean, regional aspect in this sense. If they receive additional assistance or the remuneration or the benefits, if they carry out this inside of themselves and develop cyclical economics, I think it could be innovative opportunity for the goods producers. But once again, let me emphasize that for now, for the regions, it's a little bit weakly seen. Simply, I impose my point of view. Of course, maybe it's not correct, but the idea is, for instance, that any big companies open service centers in different other countries. The companies, the producers open service centers specialized for them. Maybe, of course, can be one service center servicing several companies in order to have service center and receive for recycling, such as wheel tires, TV sets, packaging. So it's not throwing into the containers. How to organize logistics is quite a question. Yes, I agree. Yes, thank you. For now, yes, it's the level of regions. Once again, the burying at the landfills, it can be solved successfully at the nearby villages and settlements. In Vladimir province, we move it to Moscow province. On the opposite, from Moscow province, we give it to the other provinces to move the solid waste. It goes transportation and burying, and the deletion and receiving secondary resources. It is the question of the organization of our local economy. Thank you for opportunity to present. Colleagues, do you have any more questions? Do you have new questions? Colleagues, we have time. Our speakers didn't show up. We expected we have time. Yuri Alexandrovich, maybe we give opportunity to our listeners to ask questions about all presentations because we were in hurry. Now we have 10 minutes before the break. If colleagues want, you can ask questions to any speaker. If you have questions. What do you think, Yuri Alexandrovich? If you have no questions, our agenda is being fulfilled for this section. Maybe we make our listeners to have free time. I think we should start break earlier. Maybe we should come back earlier so that in case if somebody comes back, we can continue. Let's start our break. Okay, let's have a break. Yuri Alexandrovich, maybe somebody wants to listen and they come on time at 11:50. So colleagues, we have break till 11:50. Is that correct, Yuri Alexandrovich? 11:50, we meet back after the break. So till the end of the break.
Ой, меня слышно?
Да,
То я
слышно.
решил с этим.
Роман,
Александр Соломонович, можно задать вопросик?
Alexander Salmonovich, can I ask a question if he's still here? Alexander Salmonovich, he hasn't lived. Alexander Salmonovich, my question is, you showed the model realization of your optimization problem. Did you apply it in practice? If you did apply it in practice, how your model results combine with the factual results, or only planning to do so?
В том числе финансирование.
I mean, including financing or cost cutting of the used technology. We simply received from one of the enterprises, received information from one enterprise that is necessary to have for choosing technological process. They work on galvanics. One of the shops is galvanic shop. They have this problem, which technology to choose. From them, we received parameters for all operations. And we tried to model whether they accept for the real usage or not is still question to ask. Seemingly that we convinced them that the variant we found is the most optimal. What will happen next is not clear. In any case, the pictures that I was showing for illustration purposes, they correspond to reality. Alexander Solomonovich, I have one more question. I'd like to ask question when you were making presentation. If the conditions change or additional best available technology shows up, I mean financing, for how long you have to change your technology to determine the most optimal one? You know, if we talk about galvanics, then it's very complex and very expensive and takes long time. But the permits are given. I'm not ecologist by trade. I'm afraid to misguide you, but the permits are given for several years ahead. We launch a line today, receive from the supervisory bodies permits to use not the permits, but the norms for the pollution for several years. If, say, in 5 years, new principal technology shows up, these limits will be reviewed, we'll have to change something. If we talk about less costly production facility, and if every industry is special, galvanics is very difficult, it's very inertial industry, inertial operation. If you launch it, it's difficult to stop. Everything is very expensive, and things happen not fast. Okay, I understand. In such a way, it's better to look in detail and select the most optimal technology in order not to rearrange the whole system. Colleagues, any more questions? I have no more questions. Break. 11:50, we'll meet back.
Уважаемые коллеги, начинаем нашу вторую.
Dear colleagues, we begin our second portion of the presentations. With the presentation in this part, we'll have Yuri Alexandrovich Koroblev. Yuri Alexandrovich, you have the floor.
Да, спасибо.
Yes, thank you.
Так, сейчас, секундочку, я должен продемонстрировать.
Just a second, I need to show the screen.
Видно экран?
Can you see my screen?
Да, все видно.
Yes, we can see it all.
А, Вообще мой доклад посвящен
My presentation is about numerical method in order to restore the function for integrals that is used for the method of analysis and forecasting of the rare events. I will briefly remind what I'm doing
для чего это используется.
and what's the purpose of this.
Идея заключается
The idea is as follows.
Существующие методы
Existing methods of analysis of the rare events suppose that there is a flow of events. At the same time, the data can be mixed and not mixed, and existing methods offer to build time series or unite in the flows to analyze through Poisson processes, non-Poisson process, maybe Marx processes, and some methods are analyzed like this. And my approach is that rare events, I suggest to break down into the sources. So from one source as one series of events, series from 1 and 2 and 3. After this, I switch to the next stage. It's presupposition of the kind of the process. I suppose that the processes that are formed in some sources, events are created by the process that works at given source, and the result of this process are events. And if it's possible to invert the process to receive the reverse function or conduct a regression, you can try based on the discrete events data to recover the parameters of the process that is located in the source that give birth to the rare events. And further, it's the technical issue, and you can use any other mathematical methods to conduct extrapolation of the pattern. You can analyze the pattern and dynamics. If parameters are changing dynamically, we can detect and analyze extrapolation. And further, after extrapolation, we launch again supposed process that is in the source and determine the discrete events of the future, meaning we can do forecasting. Once again, on this picture, if there's necessity to receive forecast as the time series, not a series of discrete events, this event, for instance, aggregates by intervals. We see dependence, how many events took place, and so on. Such approach is being used, for instance, while analyzing the consumption process. It fits very well to the consumption process, and it fits the needs of analysis of some processes. For instance, events such as the shearing, so we can determine what is the average rough speed of the growth of the hair, or the growth of need to go to the hairdresser. Next, I switch to the topic of the presentation. So the topic of the presentation is cross-validation for integral spline, recovering the speed of consumption of the rare events. Colleagues, can you hear me? Before I give presentation, have any questions regarding the things I just said? Yes, we can hear you, Yuri Alexandrovich. The questions naturally are being posed by the previous report. They are not disclosed yet. After presentation, we'll have questions. After you disclose, of course, the calculation, the method, I said in general terms, but the essence is that the consumption process is determined by the known events that are fixed. And we can, yes, it's clear. The goal setting is clear. Let's go back to the objective to restore the function using integrals. When, for instance, we consider common process buying goods in a store, we observe TI and the purchases YI. And if we know, we suppose that next time the customer comes when previous purchase is finished and the stocks depleted, the customer makes second purchase. We go to the problem of the next time. We should minimize the following expression. YI is the integral. I'll remind you, I'll explain that the observation is with the error. YI is not true value of the source function used in consumption. There is a deviation of 15%. Our objective is to determine GT, so the sum of the squares of the deviations of integrals, also the weight of every observation. If you have desire to ignore some observation, the weight is 0, increased by value above 1. And the second component is non-linearity. Such restoring minimization of this expression, the parameter of the algorithm is coefficient of smoothing of alpha. More is alpha, more is the fine penalty. There is algorithms of selection of the, or rather, before we developed the next method of selection of alpha, we had to select visually using naked eye. So we see what is function smooth, not sufficiently smooth. We select to smoothen the noise in order to have restoring function that it doesn't change. And dependence, then the method of automatic selection of this parameter, alpha, smoothing parameter, is also called Tikhonov's realization parameter. And this procedure is based on the cross-validation. What is cross-validation? I'll tell you briefly. For any problem, idea of cross-validation is that a function or procedure of assessment of function should be efficient. That is, our function that comes out should possess minimum dispersion while forecasting next observations. And unfortunately, our problem of restoring function based on integrals doesn't have next observations. We have set of data, and the new observation is not there, but we must, based on this set, know the dispersion, make it minimal. In this case, cross-validation is assessed as follows. Calculation of dispersion, that is CV alpha, as follows, where observation-wise, subtracted integral on the function, where I observation is past the function of restoration of spline. I don't touch it. It misses I observation. What is square is deviation of restored function without I observation and the value of the I observation. And sum up of all observation from 1 to n. I is assessment n minus 1 times assessment of the function of t, minimization of expression for CV alpha regarding alpha provides efficiency of our function g of t for the set of data. Next, this function is very burdensome because assessment of n minus 1 times of the function is a laborsome process, and also minimization of this expression requires to solve nonlinear problem. Nonlinear problem is solved with gradient methods. Every time changing alpha, we need to conduct this assessment and calculate these functions. It's very laborsome. That's why we need to simplify this expression, and it is simplified as follows. First of all, I'll tell what is assessment of function. Well, absence of I observation. In the source expression, when we minimize the sum of squares, deviations, we miss observation. It's enough to suppose that the weight of I observation will be equal to 0. Usually the weight can be equal to some set value, but for this I observation, the weight will be equal to 0. In this case, this will provide that we restore our function with missing I observation. Formula is based on the work of Green and Silverman. The logics of calculation is very similar, but it is adapted for our needs to restore the function based on integrals. Earlier, I didn't tell you yet how exactly restoration takes place. This optimization problem can be presented as the matrix operation of the following: y minus matrix C with vector G. See this expression here, where integral from spline of restored function can be written down as the multiplication of I line by the column G. And solution was received as this expression. If you wish, I'll roll back. In order to create a formula that simplifies assessment of the cross-validation, we replaced vector G as vector as A alpha by Y. We leave Y, as for the rest, is replaced by matrix A in such a way. Next, lemma from Green-Silverman adopted for our problem. Lemma is this: what if the value of restored function, in this case of our spline, according to the expression A times Y, Y is all set of data, the value of G that restored I observation we can have in the following way: the same alpha matrix multiplied by Y vector instead of I observation is the value of this assessed function. In essence, I forecast value. And the proof of this lemma is quite simple, because in the basis of the assessment of the function is minimization of the sum of the squares of deviations. In order to pass I observation, we suppose that I is 0. But we can do it differently. We can take WI weight, keep as original, and replace the content within the brackets. Suppose that expression for observation equals to 0. What should be done? We should replace observation yi to the forecasted value. We replace with forecasted value. As the result, we have that expression for having assessment of function for the selection of observation is the same matrix A times Y. I is replaced for the assessment of function. Assessment of function expression cannot be directly used because assessment of function will not be known until we calculate G vector. Unfortunately, it's only analytical equality applied further. Further, we need to express a new formula. I will not elaborate here. The formula is transformed to the difference of the current observation minus integral of the function which assessed with the selection without observation. We need to write down what does it equate to. And slowly disclosing this expression, we come to the point that the difference y minus integral of function assessed without I observation is observation minus integral of the source function, including I observation assessed with full selection plus bracket. The multiply is lost here on the screen. It's yi minus integral from the same function, from the function without observation. We move it to the left, take it away from the bracket. So the multiplication, what is in the denominator, and the source is built up. So we have denominator like this. As the result, we have expression of cross-validation for calculation of this value, assessment of dispersion of forecast for set alpha. It depends only on the function calculated with full set of data. And this expression is much simpler because enough to assess just once the function with all set of data for the set value of alpha. Minimizing this function, we find necessary value. Here are examples for the correction of formula. In this case, restoration of function with integral looks roughly like this. It's stepped value, observation divided by the difference of time. It happens that the restored function, the square at some interval, is approaching the square under the step. Square under the step is observed integral. That's why it happens that the square under the curve is approaching square under the steps. The steps are with error. There is a smoothing of the integrals. I didn't find the problem solved. The all are interpolations. The square under the function equals to the square of integral. It's observed integral, but considering the penalties, it can deviate. The next correction, since missing of the first observation guaranteed leads to the function at the end of the segment goes down or somewhere to the top. If the step was in the top, it leads to the fact that square under the function different from the square under the step, and guarantee at the end of the segment, if we miss observation, the assessment will be dispersion over exaggerated. So I suggest to use n-1, the value of the observation. The value of observation, I suggest from every end to remove one observation, and formula will be like this. In conclusion, we have this assessment of cross-validation minimized by the gradients determine optimal value of alpha for the set of data, given set of data, and our function g of t is efficient from the standpoint of forecasting. It gives us the forecast with minimum dispersion. As a result, we have opportunity to automatically restore function. We don't need to conduct visual comparison. With the help of this algorithm, we can restore function of speed of consumption of products of concrete customer whose purchases we observe. If he buys from us, we can know, based on the dates of his purchase, how quickly he consumed his products. Although I must tell you here that for some sets of data, calculation of cross-validation sometimes can be too exaggerated. But sometime later I'll tell you. Hereby, my dear colleagues, this is end of my presentation. Have any questions? Please, colleagues, questions to our speaker. Thank you, Alexandrovich. Very interesting presentation. Have any questions? Yes, I have question. Small question. Yuri Alexandrovich, I sort of didn't quite understand, so maybe my question is, I understand that your integral changes by the sum. You calculate the sum. You assess the function based on sums. Second question. Okay, do first one. I'll explain. While creation of formula on this slide, I collected all presentations. I can explain how I created the formula. While getting the formulas, let me find. The integral itself will be replaced by, in essence, you see, expression of minimization of the sum of squares. You calculate not integral, but sum. Analytically calculated. Matrix C is calculated dependent on how spline is located, how the observation points. It is necessary to determine G. G is value of spline in the point of J. As the result, we have integral of this function is set by the multiplication of I line by the J column. This is simply its simplification. I take this expression and put it here. This replaced by this, because this is equivalent. Okay, understand. Thank you. Second question. I didn't understand coefficient. Omega, W, is it WI? How you calculate WI? Omega is weights set by the user. Set by the user. By default, we accept them equal to 1. The weight of the e-observation. If we want to pass observation, I set I equal to 0. And the assessment of function, where you need to pass I observation, happens like this. Instead of weight of I observation, we make it equal to 0. It can be different. For the set of data, we establish the weights different from 1, 2, 1, 3, 5. With these weights, we can assess function. At the result, we have the source function. In order to toss the observation, we believe it's equal to 0. Did I answer your question? Yes, I understand. And then the last question. As I understand, you, with the help of your method, of your approach, you set the missed value unknown, as I understand. Is it correct or not? Or still given method can be used for the forecasting of the future values of events? Yes, it's exactly for the future value. The function itself sets the speed of consumption. If we have volumes of purchases, if at the moment, from the standpoint of supermarket, we see that a customer, is from the standpoint of the supply to the department store, supermarket. At this point, it orders so many bottles of soda. The difference between next shipment, I can understand the medium function. If the volume divided by the difference in time, this is average speed of consumption. Supposing that shipment finishes when the stocks exhausted of the previous. In this case, we restore function of speed of consumption. And if we analyze it, extrapolate, by the way, due to the algorithm, with the help of the change of weight, change of smoothness of function, we can have one kind, second kind. By stopping at some variant, you can conduct modeling, conduct extrapolation. As the result, with the given set of data. Sorry, I'm trying to find the slide. But for the haircutting, when the client comes to hairdressers, the fact of cutting hair, not the volume, but yi equals to 1 is the fact of purchase of the service. Forecast, we restore the function that can have such interpretation in relation to the speed of the growth of hair and the frequency of haircutting. This function is extrapolated and we launch the process. We can determine future moments of appearance of the rare events. So this is the idea, this idea of the method. I hope I answered your question. Oh, yes, thank you very much. Yuri Alexandrovich, I also have to ask 2 questions to you regarding the algorithm and approach. As known in classical science, regularization is in order to smoothen high frequencies. And this alpha also works that that derivatives doesn't impact the process. Out of this, the reverse problem solution is because higher derivatives, the coefficient of regularization, if you My question is, in your case, are they at first, you didn't plan it for the values? In your case, selection of alpha conducted how? Is the user supposed to be? It's complex question. And the question regarding the weight, also complex, because many things depend on it. The precision of forecast, how much? Is there a guarantee of precision of the forecast? Because a man may not have money for haircutting, he can pass haircutting. Although it's time for cut hair, but he decides to pass it. Explain how the algorithm works. First, I'll start from the regularization of Tikhonov. In fact, it's needed that in cases when the problem is not set correctly, make it correct. The thing is that restoration of function using integral can be done in many ways. There's, if I toss this component, only this will stay. We can conduct the function by infinite number of the ways, so this will be minimized or approach zero. In this case, we need to conduct regularization to set a problem properly. In the method dedicated to the smoothing of splines, alpha is called the smoothing coefficient. The problems dedicated to reallocation, restoration of function, oftentimes the coefficient is called regularization coefficient, and so on. In my concrete case, if I make alpha exactly zero, the matrix expression, the matrix will be singular. There will not be a reverse matrix. In any case, I need regularization, and with the help of which we set the smoothness of function. This observation is regarding. Can I have a commentary expressed? Situation is this. If you don't smoothen the curve, you don't need alpha. You don't have additional members of the series. We need to simplify the curve, and solution can be conventionally, it's conventional things. There's nothing absolute. It can be steady. What is the regularization and singularity of solution? And I said in my presentation, the essence of Tikhonov's regularization that regularizes stability, not for improve the appearance of function, to restore the appearance of the function. Yes, you're right. You have any other works to continue Tikhonov's work, but the classics is this. Yes, you said it right. If this is not there, we'll have an infinite set of solutions. With any value of alpha, we have one solution. If we change this alpha coefficient, the solution will be different. That's why it is called sometimes coefficient of smoothing. It's clear, smoothing. What it is the range? It's done before the experiment. If you don't use this mechanism of cross-validation, it happens before experiment. I can launch some example of restoration of function and appoint any coefficient. In this case, here, for instance, alpha coefficient is 10 in the power of 3. I can have it 10 with the power minus 1. In this case, in some sense, Yuri Alexandrovich, in order to understand you, it's very interesting to hear what you're saying. It's overacting. With absence of cross-validation, you have to visually to compare. With the presence of cross-validation, from experiment to experiment, you in essence do overspilling. Overspilling, spillover is not big. In essence, is over. It's not optimization in terms of local or absolute extremum, but it's extreming. You calculate once. If you don't like a point alpha for the second time, so you make selection. Minimization happens with the help of gradient methods. When expression CV alpha minimizes in relation to alpha. Oh yes, CV alpha is the value of the sum of the squares of deviations for the function without I argument, without I observation, summed in all observations. Initial value. Do you set initial value? No. At this point, I set alpha, and you calculate with this alpha. The rest is set. I understand the rest is set. At first, to be closer to extreme, initial, how to select initial value? 10 in the power of 5. In relation to it, algorithm will go to the lesser side. The starting value can be any. I conduct minimization in case on the grid. I take 10 minus 1, 10 minus 3. In relation to this point, I find local extreme, and then global extreme. The weights, that's question. I didn't quite get it. As for the weights, as opportunity to set the goal.
You can set weights to miss any other, not miss, but to diminish 2 times the weight or increase 2 times. This is only from the viewpoint of a scientist, researcher. He can choose any weight for any observation. So, for example, I can take away the weight, this one, from this observation that we have a spike here. What should I do? I presume that the weight I assign it with the help of the weight matrix. But there's some signal, something worked badly, because the function of v is equal to 1. I'll write it. I take it and I miss the second observation, and then my first is taken into account, others taken into account, and this is the spike is ignored. And you can yes, it's done after some preliminary analysis or before. So you change the sample by changing the weights. Yes. On the other hand, I can make the one observation, make it the 100 times more, and then it will come closer to some value. What do you think? I don't. I will ask you the question later about forecasting. What do you think? If we take regression and to determine using the regression, we do not change the character of the model, the forecast values. Will your method be effective? Well, the regression in the classical way as we know it, it sets not discrete data. It determines, it's built according to temporary rows, and in some known values. If you can see my cursor, the blue graph, I can build some model, and in this case I analyze the discreteness of events, and all the data is inscribed as discrete events. But you can discretize, it's not a problem. No, we won't be able to do that. The problem is that these data present integrals. In this case, it will not be this particular function, which is as a ladder horizontal. It will be one spike, very high, which will contain, which will contain big value equal to the integral of that function, of that ladder. So discrete values will be smoothed out. It's a little bit different thing. Thank you, Yuri, because so many questions. Thank you very much for a very interesting presentation. Probably we should move on to the next one. Leonid told me that he has classes and then he will a conference later and he won't be able to speak. So the next one. Then let's ask Mr. Zhukov, Roman Zhukov. Roman, are you ready? Roman, yes, I will try to switch on the demonstration. I hope you can hear me. Yeah, Roman, you're even a little bit too loud. Can you take your mic a little bit away because you are a little too loud? Okay, thank you. Just a little, not to breathe into it and not overload the mic. Thank you. Is it okay now? Yeah, better. Can you see the screen? Yes, we can see the screen. Yeah, we can see. And open the lower button. Good afternoon, dear participants. Now we present multi-criteria optimization of the functioning of hierarchical socio-economic systems, mainly aimed at giving some tools or method to help the decision makers to make better managerial decisions. It's clear that the existing managerial system on different levels relating to different management levels means the necessity to concur the decisions on different levels, to bring them to agreement, which should be aimed at increasing the quality, the living standards of the population. And the difficulty in management is that there is a multitude of relationships inside and outside the levels, which means the necessity of using the modern instrumental methods and mathematical modeling in decision making, managerial decision making. In this case, it is clear that different IT systems are used instrumental means on different management levels. However, in the majority of cases, decisions are made on the basis of expert assessments. And very rarely, with very rare exceptions, some mathematical apparatus is used. Due to that, there appears some succession of actions, of activities that could be implemented or could implement some tools, appropriate tools in managerial decision making. First, it relates to the identification of the hierarchical social and economic system, constructing the indicators to assess the different types, and using the stages of analysis synthesis of managerial decision that would allow to find some conditions or factorial indices that would allow us to reach the target values. So the goal is to set and solve tasks of multi-criterial optimization for hierarchical systems in search of such factors where the indicators of assessment would reach the target values, and the object of research was hierarchical system as the Central Federal District. So the two-level system and the object of research is the ongoing social and economic processes allowing us to establish some dependence, general dependence between the resultative and multifactorial conditions where it exists. To describe Let's go to the procedure. First of all, we should identify the elements that we would like to study and to optimize their status. And it's clear that the research is mainly based on the works of Thomas Sati, Michal Mekserovich, and others that allowed us to identify hierarchical systems along with other structures. And based on such structures, we can see publications relating to the optimization of both hierarchical structures and the functioning of individual elements of them. And to study some level, we can look into the elements in their groups to look at it as a kind of a subsystem on each level, and we think that the classification on each level is of the same type. Multitude of classification existing presented on this slide is determined by the viewpoint of the author, and it's just a look at the same system from different viewpoints, and the multitude of classification engenders a multitude of identifiers that can determine the state and the results of functioning of the research object. Examples of such indicators is the indicators of sustainable development, of quality of life, of GDP, which is mainly used, and they are mainly used to assess the functioning of regions, of subjects of Federation, Russian Federation. And now, according to the publication of Mickey, if I'm not mistaken, for the time being, no new indicator was proposed that would allow us to give a more adequate assessment of the functioning of the regions. Apart from the gross regional product, though there are proposals to that effect, and some other indicators as well. So, the presence of indicators of assessment that we can put together could be given some management task here. And here we should understand the necessity to bring in line some factual results or to some normative values or expected values that could be calculated with the help of some models. So the model means the use of certain functions and also the management model based on the combination of the traditional and technical economic approach. And due to that, a result of such an analysis was a methodology that is proposed. First is the description of the hierarchical system and the classification built in the model to put together norms, building private and integral indicators with the use, and also the search of optimal values of the factors of impact, where the results would be in line with the expected value. And the first of them is the identification of hierarchical system of economic means of the separation of the system into levels, breaking down into levels and classes within that level, and elements that are grouped within certain subsystems. We have 3 index enumeration, and if we split them into the layers, there will be 4 index enumeration, and this enumeration is very convenient when using some instrumental tools to identify the appropriate elements. Classification could be once again done by different ways. An example is just breaking down into social and economic subsystems, but in this case, there could be cross-section between these sub-levels, so the classification will be not very correct. Another way is we can split it down. We can use the economic system, subsystem, and split it into sectors or sectoral or temporal, space and temporal. This will be just one viewpoint at the same system, but from different standpoints. Each element can be characterized by four types of the result of functioning, the conditions of functionings, and the management actions. The fourth factor is normative, that could be calculated based on the production function, that could be derived from this equation, which represent the interlevel link between the elements, and it will be a sum of corresponding features. And in this case, we can propose two types of indicators. First is a particular indicator of efficiency relation to the normative expected value. In this case, an example could be the volume of regional product, standardized and normalized, and I will be telling you about that later, to the expected value in the totality of the regions included in the federal and integral indicator is built the same when we put together certain elements and we characterize, for example, a class or a certain individual. Yes, a class, for example, an object subsystem that includes the elements that do in A, B, C, E, within the hierarchical system. A peculiar feature of this integral indicator is the fact that it takes into account the correlation between certain subsystems. From the geometrical viewpoint, virtually it's a kind of a length of a vector in the bases where each of the axes is a resultative feature. From the economic viewpoint and from my viewpoint, this indicator takes into account also some synergetic effect of economic activities. Like as an example, also this element has some useful features, universality of use, possibility of use at different levels for different elements and classes, and its measurelessness being very wide, which allows us to take away the impact of the measurement units and can bring down the scale effect. And we can introduce some coefficient of harmoniousness, and that results and is not aligned with the deviation of some indexes from. Also, we can use the efficiency indicator is relation to the change of factors. And after we have identified certain functioning results of the system, we can set some criteria which will later be used to optimize the state, the status of our subsystem. As such criteria, we can use the generalized efficiency indicators, and the factual values here should be within certain limits that could be set. The second stage, we say if the conditions are met, then the functioning is satisfactory, otherwise optimization is necessary. Then optimization procedure is conducted. And I will show you later how it's done. And fourth, elaboration of measures aimed at reaching the target values. The special features is the composition of functional forms of models, which are different from the target function, and the system of limitations. And there are two options. In the first options, we look for the factors which gives the correlation with the normative. And the second option, when we use two models, the first model is built only for the special element, and the model for the totality of elements. An example could be a model for the Tula region and a model for based on data for 17 regions within the Central Federal District. And optimization procedure, the target function is put together, and from the selected indicators of efficiency, in the simplest case, this is the sum of the indicators, and such a formal description allows us to identify the aims of modeling, and the aim is the correspondence of these indicators to one. They should be one, corresponding to one. Then we can write it down, the function, the target function, which is represented here, where in the enumerator is the difference between the factual and normative value, which we're trying to maximize, and the lower we see the change in factorial characteristic with minimizing the cost for the change of the efficiency. And this task could be brought down to a simpler linear one, but it's not necessary to do that because there's quite a big set of tools which allow us to resolve this task directly. In the simplest case, there is a chance to optimize the particular indicators if we want to optimize some kind of activity in the region, and we can use different tools. For example, our own programs or R, or so we can use different instrumental tools. And I will get down to results. So we have put together and visualized the model of the state and functioning of the system, and it was presenting, showing the links between the resultative factors and here we have the variables used for different activities, economic activities, because before it was the original our product. For the social component, we use the standard indicated longevity of life, education, incomes as factorials indices. We use the cost of the main fixed assets, the average population yearly, the average employment for different sectors, certain characteristics relating to the type modes of transportation for healthcare, and impact factors including investment and the expenses of consolidated budget. For the social subsystem, as factors of the state, we used different demographics, ecological characteristics, and also as an impact indicator, we used investments and expenses of consolidated budget. And as a result, we received the models for the economic part. We used the applicative model of the Cobb-Douglas on the right-hand side, you can see it, and linearized model and linear models for the social component. And on the graph, you can see the pictures for the Central Federal District as a whole, where we show the actual values, the sum of the respective results for 17 regions, with the exception of Moscow metropolitan, And three types of models are used. The first model, shown by punctured line, maybe you cannot see it very well. These are models and the values of which were calculated with the help of models and data for the totality of regions. The second type of model, the sum of values calculated with the models with limitations, with the use of data for each region in separately, for the Tula, for the Novgorod, for the other regions individually, then would put together, the models were put together, and as a result, we had such expressions. Why? Because limitations appeared for the models. I will explain it a little bit. When I started doing my calculations for 2017, I had 200 plus points. And if we take only data for the Tula region, we end up with 12 points. And in certain cases, like for the A section, for example, using the method of least squares, the coefficients turned out to be negative. So it turns out that the growing unemployment brings about the volume of the regional product, which is not correct. That is why we made an assumption that probably all the models should be in line with the normative values received for the totality of the regions, but due to some specifics for the regions, there is some changes in certain coefficients. That is why, as a limitation, we made assumptions that those coefficients should be within the fiduciary interval received from the model for the totality of the regions. That is why we have these limitations. And also I gave the data here that were calculated based on the models with due regard for the limitations. And I have a graph to that effect. So for each of the sections, we have the graphs and then the model for the Tula region for certain separate sections and calculated within different options. And based on that models, we had the efficiency indicators for different sections of the system from A to O, and S1 is the raw materials sector. This is a subsystem. Then the market service, non-market services sector, then the manufacturing sector, D, construction sector, so we have it separately. This is F. Also, we calculated the total indicators of efficiency for the separate sectors, the process and project subsystems, and generalized efficiency indicators for and this normative in the circle, and with this daisy diagram you can see the disbalance existing in relation to the normative and the actual values, and this calls for some kind of optimization showing this efficiency result. Also particular if the results were calculated in separate regions, individual regions, and this is another view to the one of the same system. And a result of optimization was that these results were a little bit different separately for each of the regions, and in the totality, given the norm on the level of the federal district. And here we use the model that were built for the whole district, including all regions, or for the whole Russian Federation. Models used First, for the totality of the regions, model built for the totality of regions and for each region separately. And here we have the slide scheme. Here are the efficiency indicators that should strive to 1 on the level of the district, and they're calculated, each of the elements is calculated as a sum of the appropriate components for each region. For example, of the Tula region, sub-regions, and optimization of each indicators for the region, and it strives to 1. And as an example, based on the result of optimization, we show on this slide which changes are necessary in the employment and fixed costs, depending on the previous value of the efficiency value. And you can see that in the last case, it's the red line. It shows us that there is some balancing of corresponding indicators for the regions within the Central Federal District. Here we have the C section, D section, and actually we received quite a lot of solutions. And the conclusions that we had as a result of optimization, unfortunately, in certain cases, it's impossible to completely balance everything. And big deviations between the factual and normative values of the factorial indices, they move to the borders of the system's limitations. And to do the balancing or optimization, we should use cycles, management cycles, and use certain delta for each cycle to provide for some kind of balancing. And in conclusion, an optimization algorithm was proposed on the example of the regions. We had the values of factors that bring together the factual values with the target values, and the values can be used as recommendations to change the policies, for example, for in employment, the policies in investment, in certain sectors of economy, which will be aimed at improving, increasing the living standards. Thank you for your attention. Thank you for your very interesting theoretical and practically wise report.
Every time you present some new results that are very important for the practical application, tell us, please, just interest-wise, what area in your view, which province is the most developing the most harmonically out of those you listed? The most amazing is that according to this data, if we look at the models, let's take a look at these results. I was trying to understand. It's not quite clear for me. Once again, for different regions, this type or that type of area of operation, we should make a section. Maybe, did you think yourself? If not, it will be a question for the future. It's a good question. It's a good question, yes. I can tell you right now. There is a next set of questions. Yes, I remember. The best is... Oh, sure. It's section A, related to section A. This one.
12 пункт.
Point 12. For some reason, as a variable, the answer to a question, how you assess harmonical property of development of pointed out areas is interesting to listen to your answer. Having results in a numerical way, please look once again some arranging of the areas and explanation of the reasons. If you explain the factors and reasons practically in non-black turf, you have to explain the factors that are quite possible, can be corrected, because there are corrections. And what does it relate to? And we can suggest a program, offer a program of strategic development. It's practical application of what you do. Okay, look, continuation of your question and recommendations. As for optimization, I consider the employment rate as the example. If you don't change anything, the cost of the fixed assets as a result, given type of activity in this area will be growing, this indicator. I change these factors and they, based on them, you can judge these are factors such as employment rate and fixed assets. In other sectors is investments and consolidated budget expenditure. This is where I cannot give recommendations. In fact, if you take Roman, we did a lot of work in this area. If you take data from Russian Statistics Committee, even if the old data, with the help of this modeling, we can detect all issues related to the historical aspect of development of the territories, because under planned management, nobody wanted to work in certain sector of economy. And there was organization of new production facility, despite of if they want or don't want to. So they would sell pulp mill. But we look at deeper into the historical development. We see that enables that this or that region allocate a specific area of production and even type of living. Employment is very derivative factor from all other things. It happens it needed at a lower level. We have to go down to a lower level. The historical perspective is important, and mentality of people is very much dependent on this. This factor must be taken into consideration. During Soviet times, the economy was planned economy, and actually speaking, it's the acquisition and loss of our time, because industry in the Soviet industry was not steady. It was one of the central points of developments of GDP of province. We need to give a hint. It's very practical objective, so that your model can hint the managers what is missing, where's missing profit, missing benefit. If one direction, in my view, of the development of territory stands out, it should help those, it must help those to find regional equilibrium, some collaboration. It should help those areas that need subsidy, not from federation necessarily. It's an objective and key function of regional government. And from wisdom and from equipment rate, the harmonical and wealth, status of territories. Then there'll be new jobs, there'll be new sources of income, and so on. Don't you feel that way? Oh yes, you're absolutely correct. Based on those changes, we develop measures. Quite interesting combination of previous presentation of Yuri Alexandrovich. Now, if you suggest the algorithm of forecasting of consumption on the condition of what you do, it would be correct to integrate your approaches with the purpose of perfection of mechanism of managerial decision making. You see, there's opportunity to cooperate scientifically. I will not ask questions about all formulas, because I understand that Yuri Alexandrovich, do I say correctly that at 1:10 we should have a break? Yes, we have a break. By the way, my second presentation, I would put it to the second session. Yes, I wanted to ask you about this, because there are some presenters missing. My question to Roman Alexandrovich regarding this presentation. Roman Alexandrovich, can you tell us on these diagrams, the black circles, deviation, which one? Any one you like. I'd like to know technically, deviation in inwards and outwards. What is positive, what is negative? If value of indicator is above 1, it is believed that this region, this province, works satisfactory. If this value is below 1, you see, then this indicator doesn't reach normative value. See, black circle. This indicator of resultativity for every region. All right, clear. A non-satisfactory. If above y such diagram, it illustratively shows whether any province works satisfactory or not. So if we deviate inside, inwards or outwards, it would be nice to have in other presentations, to have illustration how to have this type of diagram. It would be very nice. I can tell. Perhaps not now. Another observation I wanted to make. Look, as far as I remember, black circle is the planned indicator for every province. Plans differ. Am I correct? Yes, you're correct. On this diagram, each diagram for each province, black circle can be different because plans are different. Look, yes. Sorry for interruption. Plan is the circle equals to 1. And this plan is being formed with consideration of these factors. The impact, this is plan, is calculated based on the current or de facto values that are peculiar to this particular province. So this is 1. And further, with this normative value, we have factual numbers. And this ratio shows and reflected by this diagram. And this ratio preliminarily is standardized, which I spoke, and then it is normalized. My observation is that I can take this petal diagram and compare it to another region, because the contour contains different meaning, different value. Yes, please. You're welcome to look at this. A central circle for one province and for the other has different values. Oh yes, this circle equals to 1 in principle can be different for each region. So maybe it would be logical for us to come to a level that the target or planned indicator for all regions reflected by the dotted line on this picture and the circle inside should be uniform for everyone. So the source or the basis of all graphs will be the same, and on this basis for one region has one curve and the plan with different contour. It happens that we need to switch back to it. Look here, we need to use this type of models where it shows, for instance, de facto plan according to this model and to other model. This in essence is normative presented for certain area. I like the circle diagrams are more illustrative because it shows many variants. You show plan, not show this type of curve, and this is fact. All right, now it's clear. Yes, we can present in absolute numbers. For instance, these pictures show 2018 data. It is clear that it should be done in such a way to see dynamics.
Ну, спасибо тоже за
Thank you very much.
Я бы хотела, Роман Александрович, подчеркнуть тоже.
I'd like to highlight that I agree with you, Alexandrovich. This diagram is very indicative. If we interpret it that the circle is plan and everyone has personal plan for particular province, they illustrate, let's say have proprietary plan in relation to one, in relation in second case, one area, number 2, and the spike, it means it doesn't have to be too well. It means resources. It's based on resources. Development is based on resources. We need explanation, and we can tell exactly how good is this, even if it's outside of the borderline of, if it's the overperforming the plan. Certainly finish this work. It should be done in relation to the complex plan, and I explain why. So we can make decision. We need to have a program of decision making. We need to know the reason behind this. The program, the commentary, decision making usually has fields, the reasons for different situations, how to correct situation, how to remediate the situation. But your problem is not this. And also about modeling, I'd like to draw attention to the fact that the indicators are being changed. I'm not sure that they are normative and they classify. Please check if you didn't check. Functionally or correlationally related, and money for calculation. Simply minimize indicators from the standpoint of informativeness. Sorry, I showed 34 indicators and see what was. It was cost of the fixed assets and employment rate of population for every kind of economic activity, 2 indicators for each region, but there are 17 regions and I optimized, I selected 2 out of 17, so I have 4 indicators. I wanted to demonstrate that this is the combination. How many indicators for this province? It changes from area aquat from 4 for the transport. Despite of the revenue, despite of the universal objective assessment of this particular development, there are 134 indicators. Africa will send one, Asia will have another. Maybe they're not too optimized, but they are for all countries. All countries send information and then accept it. And here you have to have universal assessment system. Otherwise, it's difficult to judge. I'll tell you more. Sorry for keeping you. As the resultative indicator, we used gross regional product. It depends on employment, cost of fixed assets, investments, and the cost of the consolidated budget. It's derivative. This indicator is derivative. There are plants, there are jobs. No plants, no jobs. There's the question of correlation. That's why maybe should not take it in consideration. We should consider what is more informative, more indicative. For instance, development of some sector of industry or scientific institutions or some natural resources depleting industry. In this case, we should have some optimization with usage of resources of territory. If there is a Lake Seliger and the plants suggested to be in the plant, he said money will come to my pocket. Otherwise, on Seliger would have this zone is not for Russia, it's for entire Western Europe. I say it for example sake. I'm so concerned with this issue because such models are very important. It's great that you develop such models. Thank you very much. Yuri Alexandrovich, so we declare break. So we meet back at 2 o'clock? 2:20. 2:20.
До 14:20.
Till 2:20.
Здравствуйте.
Да, здравствуйте. Это Анна Викторовна.
Да, Анна Викторовна.
Вот сейчас сейчас будет мой доклад, который вот с предыдущей части до перерыва должен был быть, потом ваш.
Хорошо, спасибо.
Здравствуйте, коллеги. Еще раз. Как, Юрий Александрович, начинаем или подождем?
Ну, давайте еще 4 минуты. Мы же обещали в
Да,
20
да,
минут
давайте
начать.
уже до того времени. Хорошо.
Микрофон. Включить, да? So, colleagues, good afternoon once again. Let's go on. Now, I will tell you about the results, some more results, which we will get under the project we're doing this year. Can you hear me? Can you see me? Yeah, everything is okay. So my first presentation, probably you got an idea what I am doing. And the second result that I would like to share with you, there was another guy. So the research of the, and I would like to remind you, so we have some events, discrete events, and Y, And in terms of the consumption processes, you can see as an integral of the function of the speed or the intensity of consumption from one event to another one, not necessarily that these processes will be process of consumption or maybe increasing some problems, but by these discrete values, we can restore this function. And it will remind you that we have a mistake, epsilon it. A lot of reasons behind that. I won't get in detail. Could be just inventory replenished not in time. So the aim of that research to see how the uncertainty inside the process events impacts the quality of the preciseness that we will in the hidden function. Certainly nobody will give us this function, but we can do it during modeling. So different uncertainties will be taken into account, but here 3 points I would like to determine. The most general case, how the uncertainty of the final observations, they have some mistakes that we will vary. Then mistakes in inventory, and then mistakes in the data. And we would like to determine this, the final mistakes. The methods is imitation modeling, because only there we can set the f of t function, but nobody will tell us from above which one it should be. We model the mechanism of events like we model the system of managing the inventory. There is consumption, inventory come to an end, a consumer goes to a store, and then he buys as much as he can. So he replenishes his storage until some maximum value. Here I determine the preciseness of function. This is I, capitalized with index I, small. And non-precise observations, those are those with mistakes, because the client would use some insurance inventory, Y, and precise is I. And we can see the average deviation. And we can also determine the average square deviation from those deviation to compare how the precision depends upon the uncertainty, and what we are going to do will restore the function of f with accent aigu and see how accent C conflicts, and in relation to the mistake. And I would like to determine the link between this R assessment, the re-establishment of the initial function, with the spread of actual observation, the previous one, the spread in this value. And for starters, I would like to say that first of all, I do the restoration of function for real integral. I will replace and I will restore the function. And it turns out that for true integral, the restoration is not ideal, because at the ends of the interval, at the very beginning, at the very end, we don't have information about where the function strives further, because we use splines, and one of the features of the natural splines, though it's an integral one, that at the ends of the intervals, at the very beginning and very end, the second derivative becomes zero and becomes direct line eventually. And here as well, So the function doesn't know where to go, and also because we cannot fine-tune the smoothing out. Maybe at some points we will have not enough. Here it will be reach the original function. Maybe we will have over smoothed function, and in advance we don't know which coefficient of smoothing to set, but we can use the mechanism I described before, and as a result it so happens that given the zero deviation we have the mistake of 3%, 3.6% restoration. Then I move on to to other experiments. And the mistake of real observation, how I said it, I take the true values and from them I use the mistake, and it will be a relative mistake to be expressed percentage-wise, and for each value for the spread. So this, I model this mistake with normal random values with 1.5, 1, 5, 10, 20, 30%, and have 20 runs for each value. And because I will model those values, I will recalculate how random figure, I don't know how the random figures will take place. I will give a spread, and for each run, I determine the R once again, and I will compare it with the spread of the actual observation. As a result, my first value at 1 and 50, 30 and 50, I get R and sigma. At 1%, you can see it's either 0.8 or 1.1. So this is the accuracy of restoration. At 5, 4, at 20%, there will be 18, 20, 17, and some R once again. And certain runs, for example, for 5%, can look this way on the graph here. I would like remind you that it shows the average value, and at the step it's the observation itself, but it's the straight line here. So the initial average value and what is given at the intake, it's a punctured line. It's and the restoration of the function takes place according to the punctured line. And it so happens for 5% it was more or less okay. The picture was more or less okay. Certainly some small indications for 10%, which is not bad. For 20%, it is already worse. But there were certain runs, though for each parameter we had 20 runs. And eventually, if I give all the 100 runs and we put together here at 1%, which is separate here, this is at 5%, it was grouped there because it's not very visual. But if we build a model for all 100%, we have either a linear function or nominal. It describes a little better, but in the future, it's easier to use the linear function. Apart from that, several runs are given for too big mistake. At 30% observation, we see that because the observation are changing very much, either too much or too little, there's some false oscillations that shouldn't have taken place. And one of the recommendations that given a big noise, the integral with big mistake, we increase the smoothing degree level, and we lose the more often harmonicas. It could look this way, but the main, at least we will be able to restore. And we take away this, the noises. That was the first experiment. The second experiment was uncertainty in checking out the inventory. In managing inventories, every day we check out the current residue, and we see that it's below the critical level, and we replenish the inventory. And if during this comparison we also have a mistake, and how it can happen. For example, a guy doesn't think seriously, says more or less okay, or more or less not okay. But I model it once again. I put this value as a normal expectation and dispersion of sigma of the critical level, and I will take it 1, 5, 10, 20, and 30%. And for each, I have 20 runs with each value, 20 more runs. And in each case, I determine how the function restored. And I will have another table like that. And here I see that at 5%, the actual mistake is less than 5%. Here the deviation is less because, as a rule, the spread of the critical level, and since the critical level is lower than the volume of purchase usually, or at least by modeling, it was said that the critical level is about 200 with a volume of purchase of about 1,000. The experiment showed that the growth of error is slower given the growth in spread of this error of critical level. And also we can say that the uncertainty within the process could be replaced by the uncertainty of the initial observations when that epsilon is added not into the process but into the final observation. And the third, certain options of runs at 5, 10, 20%, a graph of spread, once again, very similar to the linear one. Here is a linear model, and the coefficient is different from the previous one. And the trusted interval here doesn't cross with the previous one. But I can explain it by the fact that there were so many observations that, for example, 2 times it was above the average, and it put the function upwards a great deal. That is sigma. This sigma doesn't show how the observation took place in a row or one after the other. And when they are in the row, they bring, and when they intermittently occur, to a lesser third experiment, the mistake, the error in the date of the event, I see when the event take place, and then from this event, I use the mistake in days from the interval of the between the previous event. So I modeled and I got the current event, and I saw what the interval is equal to between the previous and the current one. And I use the mistake or error sigma delta t. And modeling at 50, at 5, 10, 20% SKU for this variable. And once again, I calculate the factual and the observable deviations in SKO. And also the restoration of R, how precise it is. And since of date of this day I can deviate higher or lower, then the volume of purchase was determined before the current date. Like a guy wanted to renew the inventory before, but he buys as of the moment of renewal, of the factual renewal, because he looked at how much inventory he has, how storage he has, and he says that he doesn't need more than a certain amount. And as a result, here it's not 100, but 60 experiments. Why 60? Because when I calculate in days, it's not only even one day. And given the big intervals, it's worse if it's if the spread is 30%. I will have only 10 out of the interval. It's so the interval will be very unnatural. and it's very hard to name them deviations. It's a kind of very unnatural deviation. And here I determine the actual deviation percentage-wise in days, like 5% of the interval, the spread. No, I said the 10, but here the deviation was 8 or 11 or 13 or 20. I said 20, it was 117. And once again, the growth of this indicator resulted in the increase of this indicator, and it happened more faster by 1.4 times. I suppose that the double dispersion should arise because the first interval and the second interval varies, so the double dispersion should take place. And the table is like that. Now it's 8.7 when it was 5, and when it was 16.20, now we have 30, 27, 25, so the deviation is higher. It should have increased by 1.4. And as a result, I say that the error in the date of the events and observations can be in the future looked at as the deviation in the observation. So the model is like that. And here it looks very much like the previous one and the other. And the trusted interval here, they cross once again with other parameters. It could be intermediate variant in the first and the second case. If we look at all the three experiments, bring them together, it will be about 300 observations. And SKO of the final observation critical, the time interval, linear model is built like that, the model of mistake. And the link of the how precise of the restoration of the factual observation of error. And as a result, the error within the process affects the error of observation. We can limit ourselves in looking into the error of observation. The precision depends linear. At 5 to 10% restoration is very good. At 20, 30, false extremums appear where they should not be, but we can smooth them out and give the main harmonicas. And the main harmonica appears. And here is the end of my presentation. Thank you for attention, and please ask your questions if you have.
Please tell us. Give us reply. I can't hear anyone. Yes, we're all here. People don't have questions.
Ну, может быть, позже возникнут.
Maybe questions later. Yuri Alexandrovich, I have a question like this, if you don't mind. What's the error? How do you handle transformed error? What do you mean? A special term adopted, there's a source error, there's error transformation of the error of the source data through the calculation filters that is called transformed error, of which I made presentation today. This transformed can exceed, first of all, it correlates with the input and can exceed substantially, especially in the case of if there is nonlinear transformation. In this case, you cannot orient at the source data only. You have to look at what transformations are present, and good way to calculate transformation according to formula that practically for every calculation situation. Consider this as the continuation of your works, if you don't mind. Let me, can you explain to me, do you mean, for instance, if the deviation epsilon, it's the error of absolute result. If y is your result, that's the error that comes to one parameter epsilon. In fact, it's not like this. In fact, there is what your time depends on time. Integration is according to time. dt. Usually f of x by dx. Maybe you have two sources of data, contains error of data with the gauger. When integration takes place and differentiation takes place, or any other transformation, this gauger error goes to transformation, and it has different value that correlates in common case, simplifies, correlates with the error of the source data. Then comes epsilon. I understand it happens that in my case, for instance, if the event takes place in the middle of the day, at the end of the day, in the journal, in the log, this current data, say 25th of December or 19th of January, it happens the error of discretization of time. It's not seconds or milliseconds, it's the error of discretization. It's another type of discretization. I mean, the error of discretization is easy to calculate according to the method of Shepard. The other thing is error of integration during integration of the process. When you take integral, this error is by numerical method or dependent on function. Both errors in continuous way I see by the formula we integrate. It's only error of the source data. How precisely determine the time that you believe is the source state time. After integration, there's additional type of error that's called transformed error that in general wraps with the error of the source data. It's plus to plus error, plus source data plus the information error, believed to be independent. Very hard with permission. With any transformation, you have this error. You have to control it. Yes. This research was dedicated to this error, because true value of integral observe only those with errors. And restoration of function based on integrals happens through the optimization problem that was shown as the result. I still look at the value of restoration of the source function. Precision, this error is the restoration of source function. If it was 0.95, less than 1, then errors is 3.9. If it was 18%, the error is 996. In this case, error of information doesn't play big role. The error, look, the error of observation here, and the error of transformation will be here. This will be error of transformation. If you're interested, I worked elaborately in my practice. The quantization errors Well elaborated questions. Let me know. We will continue to work together. Good. Thank you for your observation. All right, now. If no more questions, let's move to the next speaker. Maslennikova. Hello. Can you hear me well?
А нам необходимо включать...
Do we need to switch on simultaneous translation? It goes automatically. Good. Dear colleagues, I'd like to present to you a presentation about dynamic model of interprovincial development for research of strategy of management of the urban agglomerations. In this case, group of authors. The speaker is Maslennikova Anna Viktorovna, candidate of economic science from the University of Municipal Management of New Russian University. Few words about purpose of research in this case in the Russian University. We at current time selected the topic. This is development strategy of consistent development of urban agglomerations based on the model of the interregional development. I'd like to say a few words about the history of the work and about building the dynamic models of interregional social development. And as the foreword, I'd like to address to those words, those works that are the foundation of this model. This is Forrester model, the father of the dynamic research. His global dynamics work was developed quite a long time ago, but it was laying foundation for new direction of the system analysis and modeling of long-term social economical development and in general global development. In this case, in the Academy of Sciences, I worked in the Russian Academy of Sciences in the Center of Nonlinear Dynamics under management of academician Matrosov Arkady Grigorievich. He initiated the works in our center on modification of Forrester model, and later, based on this modified model, we started to develop the model of interregional development, dynamic model of interregional development. In this case, what are the purposes? First of all, ideological basis is the works of the consistent development. It was mentioned several times today when we listened the indicators presentation, the approach of the United Nations to the indicators of the consistent development. It's the work of the global community started a long time ago, and the peak of interest to consistent development was end of 20th century and beginning of 21st century, and the Russian Federation at that point was actively participating in international discussion, drawing bottom line that took place at the consistent development forums of United Nations. The ideological component is the work of consistent development. In this case, measures of dynamic development of interacting regions impact the quality of life. One of the sources of the safe development of the state is cutting interregional and intra-regional differentiation of population in terms of quality of life. We created some new equations. As the result of the solution of the system, we make forecasts for the future. The calculation experiment, of course, the most serious problem was conducting calculation experiment that was realized at the computer system of dynamic modeling that was also developed in the center of the consistency by our employee, Mr. Matrosov. The structure of the model is quite universal, in fact, and allows to select regions based on the goals. and the experiment that we started to conduct at the beginning implied selection as the regional federal districts of the Russian Federation and Moscow as a separate region. That's why at the end, now when we started to work on more, let's say, research of the effects and impact of the agglomeration development on consistent development of the Russian Federation and the regions, this model in this case, this approach at first allowed to consider it from this standpoint when Moscow agglomeration was separated as a region, which is quite well grounded, even though we start analyzing statistics. Since statistics of the Moscow agglomeration, we joined Moscow and Moscow province. It strongly impact perception of the statistics of the Central Federal District, regional and social economic system, and the model is described by the following equations. First, dynamics of population, how we foresee inter-regional development, to see the differences that are in the real life. In very serious way, we observe how these differences between regions, how interaction of the regions can be described. First of all, it's migration flows. Dynamics of the population, in this case, expressed by differential equation that along with the natural restoration of population is impacted by the migration from the neighboring regions, inflow and outflow of population. When we draw the equation and we selected coefficients, we tried to approximate to the calculation experiment and select parameters and describe the processes so we can statistically fill this model. And absolutely agree with the opinion that we need to select so informative indicators so we don't overload the model and our calculation, at the same time to give objective picture. This, of course, is quite challenging because from one side, we have crazy number of the indicators if we start analyzing statistics. On the other hand, there are key indicators which evidence testify about the state of the region, important processes that take place in the regions, and see the dependence. What impacts what? In this case, following Serezidinov's Professor Serezdinov, the equation of the differential equation, that is the write-off, the key assets, and incoming assets. At the recent times, we started to analyze how these limits of growth, later I will tell you more about this. It is in the works of Forrester and his disciples. And this is one of the limits of the growth, along with the increase of the density of population, is also providing of the key assets. And here we try to take it into consideration. The cost of construction of the fixed assets and dependence of the fixed assets construction from the density of infrastructure. It's extremely important if we consider, for instance, Moscow agglomeration. Next, the gross domestic product of the regions described by the following algebraic expression. It's called Douglas form, is the multiplication of the efficiency of production that gives opportunity to consider scientific technical progress and the growth of performance on the workplace. This is a redistribution of gross domestic product in the regions, portion of the product imported from neighboring regions, plus minus part of the product that goes to the other regions. In such a way, product consumed in the region expressed by the following expression. Also have average cost price index, because the regions are different in terms of prices, in terms of the how they're provided, the inflation level. Important for modeling, we have to consider inflation. And the model in this case allows to see what is the difference between regions in terms of quality of life and the interregional differentiation. Presupposition, the quality of life depends on the provisioning of the fixed assets, level of salary, and density of population. In this case, of course, we write down the level of salary. Salary is portion of the regional product. Before sending portion of the product to the other regions, level of provisioning of the fixed assets is the following expression, dependent on the count of population and density of population. It's number of people divided by the square. When we shared results with the colleagues, they asked us, why do you take indicators the density of population and make it so important? I think that 2020, and I quoted Forrester Fraser, who years ago said in his work that in 21st century, the highest impact on the quality of life population will be density population. In this case, we live till this day, and those who knew our scientists and foreign scientists of the 20th century know that the crisis that we experience now, in principle, was forecasted. In fact, those long-term forecasts they implied the crisis events and the works at the limit of growth, consistent development. In principle, scientists that developed this topic, because of the activity that they held, they making calculations and analyzing and studying the question. They warned us, if you don't change trajectory of development, we will approach the situation that we are here now. The density of population at this time, especially residents of Moscow agglomeration, believe that this indicator is the indicator that decreases catastrophically perception of quality of life of population in Moscow. It is believed that quality of life on listed parameters is not linear. It has level of saturation. Increase salary above threshold, further increase doesn't decisively impact quality of life. In this case, this function is applied for description of this process. Now, using this function, the quality of life in the region described by the following formula. It is believed that intensity of migration flow between two regions determined by quality of life in the regions and different distance between capitals of those regions. Separately, flow of migration from one region to another. And there is a solution to this equation as well. With the help of this function that was shown on the previous slide, migration flows from region to region is described by the following formula. We see coefficient of mobility of population, its scenario, and distance between capital cities of the regions. And in this case, summarily, flow determined by the following expression, and summary outflow by the following equation. The constant for the region's coefficient of the write-off the fixed assets, cost of construction of infrastructure, and efficiency of production. As the result of identification of model of the previous period, because we are, of course, in the process of research, and also we're tuning the model. We see in this case the graphs, frequency of infrastructure of Moscow agglomeration is blue curve, and the model curve is red curve. Here,
modeling depending on the income, we see that the crisis of 2008 wasn't caught by the model. And according to the model, it turned out that the picture was better, but the stats show that the growth of salaries decreased. Pre-Volжsky Federal Region, North Caucasus, more modeling shows, and the Moscow agglomeration after 2008, the level of incomes of population became, so there were serious statistical changes arose that were not caught by the model, unfortunately. This is stats over the population, shows that for population numbers, we were more or less, identification was good. As a result of the experiment, we have the preliminary forecast of the dynamics of fixed assets, which shows the decrease of the tempo of growth of infrastructure. But we should understand that provision of the infrastructure should be assessed not in monetary terms, that because of the difference of the cost of construction in different regions, it will not reflect the availability of infrastructure, because in Moscow, to build one hospital is one cost, and in a different area is different cost, and that is why the importance doesn't change of that hospital. And 2020 showed that Moscow, because of the limited square, and it's limited in terms of the possibilities to provide the population with the necessary infrastructure. This is the natural limit of growth. We've reached the limit, and according to the modeling on this, we show the preliminary forecast of dynamics of infrastructure provision on the average in the country, given the inertial, and in Moscow agglomeration. So this process of redistribution, so to say, and investment in the it's inevitable, because in region we have short supply and Moscow has reached its limit. And here the dynamic of the quality of life during a given inertial development in Moscow and the central federal district, which is, and Moscow is a part of it. Look at the long-term forecast. If nothing is changed, the difference is very big. And the main conclusion made, yes, now 2020 made its corrections, but we will see how it will develop further. And the difference between the Moscow agglomeration and regions is so much that this differentiation stands in the way in the development, sustainable development of the country. And we make some conclusions that the political instability and disintegration probably is inevitable, especially after some serious crisis, and this disproportion in the living standards should be liquidated step by step. As for the Russian regions, unfortunately, this modeling has already shown that the Far East is very hard to be managed in terms of the social economical development, no matter what we do, what impacts we do. The model shows that it is not linked with other regions. If the central Russian region, they react to one another, then the Far East is really the far, and there are some non-standard managerial decisions, and to reintegrate it somehow into the Russian Federation, something should be done. And the preliminary forecast of the dynamics shows the slowing down of the growth of infrastructure, and there's a trend of smoothing down in the regions. It's obvious that we should develop different options of regulating migration flows, and we see the problems in regulating the internal migration and the process that took place over the last 20-25 years, when the population came to one point and the Moscow agglomeration has accumulated 10% of the country's population, a huge country. And are we ready to provide for the security of the population given such high density? The Chinese are ready, but what about us? The main question. Another thing is, should we do that? And this question of the spatial development, to which degree it's necessary for us to provide for the security and to spend all the resources to provide for the security, given the high density with the territory we already have. So we show the conclusions in our publications. So thank you very much for your attention, for the chance to speak at the anniversary conference, and we congratulate all the collaborators of the financial university with the anniversary. Let me start. So we, as we've done this problem for a long time, and in all the viewpoints, we looked at different levels of modeling, different levels of assessment. And we worked in 19 and 19, and we published several brochures and a monograph about those issues and indicators that you have assessed. Because of that, I have not only questions but doubts about what you have done, not about the fact that you have done, there is no doubt about that, but to which degree your conclusions are grounded. Let's start with a simple example. Salaries. We modeled it and decided not to do it because it doesn't determine the quality of life, because it is calculated in rubles in the regions, but not in rubles, but in percentage. But the price of the consumer basket is not taken into account. And when we compare those data and they're missing, it turned out that the salary does not increase but goes down. That is why your curves will be absolutely different, the first thing, because it should be regarded in terms of what a man can buy with this additional 2,000, what he used to buy before and what he can use now, not only food stuff, but other services, including education. And we should understand this very well. First, well-groundedness of your conclusions, I think it's doubtful. They are not well-grounded because what is in the literature, it was recommended, but it was recommended very many years ago when we didn't have such dynamics and volatility. And it's impossible not to take into account the environment, the external events. We all know that about the migration. A lot of proposals. If our gastarbeiters didn't come, we wouldn't have clean yards because our people are not willing to take the jobs that the people from Asia are willing to. And I don't know whether it's good or bad because this year they haven't come. And we had quite a lot of problems because of that. Traditionally, for many years, they do the cleaning of yards, courtyards, and the population grows, and people are living here, and their families, they increase our population. And we should differentiate between the population number of which ethnic groups prevail in Moscow. And you don't have this. It's very superficial. The Academy of Science shouldn't do it this way. And I will go step by step. Forecast. How can we have a forecast using only one indicator? We don't know what's going to happen tomorrow, and you make a forecast for many years ahead. And because the dynamics are very high, we build dynamic models, and actually you use stationary processes that never change. Very narrow model. And why I'm telling you that, because we've covered very big way of processing real data and developing algorithm. Uncertainty, where do you get data from? Rostat, they're obsolete, they are not very specific, and there are a lot of uncertainties there that do not allow them to use for such a direct analytics as you do. Yours is a very direct analytics, very simple formula, and the previous presenters, they tried to approach this more grounded way. They understand that the previous methodology cannot be used, and you have just the previous methodology during the planned economy. It worked there then, and Hanti-Mansi is their district. It's well provided, but the quality of life is not very good. And difference between the regions, but in Moscow, how much differentiate the population strata? Maybe you won't see it in any country because we have, rich people are also needed. That is why it's not all that was there in your presentation. I would like you to take into account, and if it's possible, just to answer those questions. Thank you. Thank you very much. Actually, we are doing our presentation to share our experience and to listen to your opinion and to take it into account in our future work. And our goal is at conference like this, with the participation of experts, to show our results and to get your opinion, to take it into account. Thank you very much. I heard everything that you've said, and we will take it into account anyway, because I was unable in my presentation, because of the time limit, to present the whole volume of work done, including stats, and to show the nuances, because actually during the modeling, it is not that generalized as it looks like. There are nuances, and this is the regional GDP, and we tried to take into account what you were talking about. And if we start sorting it out, we try to do that. You're absolutely right about the salaries. Average salaries is nothing, and provision with the fixed assets and the consumer power, purchasing power, and provision with infrastructure. So many nuances that should be used, and we are developing, finalizing this, our modeling fixed assets. As for migration, in this case, in my view, this problem, Moscow agglomeration, it accumulates, you're right, the main number of migrants, external migrants, but I do not share this view that it is due to those migrants, the labor market in Moscow is such that they take the jobs that the Russian guys wouldn't take. I do not think so. I think in this case, the situation, yes, it's as it is. But I think with those labor migrants, we are quite capable of solving this problem, and we will have to solve these problems. And probably a lot has been out of the framework. I will take into account all your comments, but you should understand that the work that has been done, including the stats and the dependencies described here, it is maybe and was not very well represented. It was generalized, and if we get into detail, then it will become clear that a lot of what I have said, we already try to take into account. That is why many thanks, and we will keep thinking about your comments and other comments. Thank you very much for your report and for the answers. The topic is very important and very, very complicated. And it's clear that no person is unable to answer those questions properly. So thank you for further development and keep us posted. And a question to Anna. And I have a question, not just a question, just rather a comment, because the differential equation in the model of this dynamics system, the dynamics of all the indicators is explained by those indicators. So the model explains itself. And that is why when we have some external changes affecting our enclosed system, already enclosed, the dynamic models won't be able to explain the behavior, to explain the changes. Maybe some external factors should be added and taken into account. I completely agree with that. It was very hard to do this at the first stage. That is once, but since the model allows also hook up other regions, the model is built in such a way. Then in the future, we hope that also the world regions that make an impact will be included. And we're getting to a state now, vice versa, from the cooperation life forces us to get isolated. That is why, in this case, this actual cooperation between the regions with the region, world regions, today, maybe unfortunately, is not so dynamic during a certain period of time. Yes, the model, the world model was taken as a basis, you are right. And that is why this external impact is hard to be included into the measurement. how the cooperation with the external environment will take place. So this is a question for the future. And this is good about this test, that it allows us to develop our stuff. Thank you very much. Any more questions? If there aren't any questions, if I can, Roman model was developed in the Ural department of Russian Academy. It's called region, model of region. Maybe you can try. Yeah, we use that model. We looked into that. We use those approaches. It's not the only model. And in the Siberian department, and Professor Granberg worked a lot in this area. So that experience was taken into account and will be taken into account. Thank you very much.
Any more questions to the speaker? Let's express thanks to the speaker and let's switch to the next presentation. Next presentation, Yuri Alexandrovich. Do you see people present here? Can we make next presentation? Yes, we have people present. Alexander Ivanovich, it's not according to the list. According to the list, we don't have any speaker. Like Mila Olegovna, yes, just a second. Irina Vladimirovna, they're in the process of teaching. Alexander Ivanovich, are you here? Can you hear us? Can you answer? It's not his time, because maybe he comes when he's listed. It's 3:20 p.m. We have listed Bogomolov. We're running ahead of time a little bit. While he's not here, maybe next colleagues will make presentation and join us. What do you think? According to the program, Bogomolov is present. He is in the network. Maybe his microphone is off. Alexander Ivanovich, maybe you switched off your microphone? I can call him. Maybe he stepped out from the microphone somewhere. He will come back soon. Then Yuri Alexandrovich, who else can go according to the list? I see Vanyuk, Vera Alexeyevna. She's supposed to work. Mikhail Vladimirovich with his presentation. Let's go according to the list after Alexander Ivanovich. If Ludmila Olegovna doesn't make presentation, Alexander Ivanovich, we can hear. Let's make next presentation. Ivanyuk Vera Alexeyevna, next speaker. Let's do it.
Здравствуйте.
Hello.
Здравствуйте.
Yes, hello. We can hear you well. Vera Alexeyevna, maybe you feel uncomfortable that you have to do earlier, but for reasons of teaching, some of the speakers are absent. So please make a presentation if you can.
Хорошо, включаю.
Yes, good. I switch on.
Так. Демонстрация экрана.
Demonstration of the frame.
Всем здравствуйте.
Hello, everyone.
Тема доклада
Topic of my
«Методика оценки
presentation, method of
предприятий на
assessment of
основе
enterprises
системного
based on the
анализа».
system analysis.
И в этой работе предложена нейросетевая модель многофакторного анализа экономической эффективности для такого крупного предприятия, как ЛГК «Росатом». Хотела отметить, что этот проект был сделан в рамках научно-исследовательской работы. Была выбрана крупная корпорация, и она представлена здесь, государственная корпорация «Росатом». И в рамках для этой организации была сделана модель. Предложена нейросетевая модель для оценки влияния финансовых
neural
инструментов
network, influence of the
и
financial instruments,
организационных форм
and the
на
organizational
динамику
forms
развития
on
компании
dynamics of development
Росатом.
of company
Следует
Rosatom.
отметить, что
Should note
сама
that
корпорация
the
– это
corporation
крупная
itself
корпорация
is large
номер один
corporation
в
number
России,
one in
и
Russia,
она занимает
and it occupies
67% мирового
67% of the
энергетического
global
рынка.
energy market.
И предложен алгоритм
We suggested an
оценки
algorithm of
экономической
assessment of
эффективности
economical
предприятия на основе
efficiency of
связочной
enterprise
нейронной
based
сети.
on the neural network.
И, соответственно, для того, чтобы
In order
построить
to build
такую модель и найти
such a model
степень
and
влияния того,
find the
какие
influence of
финансовые элементы
what
влияют
financial
на
instruments
прибыль
impact
корпорации,
profits of the
прибыль
corporation,
корпорации выражается таким
the profit
показателем, как
expressed by
EBITDA,
EBITDA,
прибыль на конец текущего года, без
profit at the
учета
end of current year
амортизации.
without depreciation, less
И,
depreciation.
соответственно, для того, чтобы построить
And in
такую
order
нейросетевую
to
модель,
build
нужно определить
neural
входные
network,
элементы и
we
выходные
need to
элементы. И,
express
соответственно,
input and
выходным
output
элементом это
elements.
будет
The
прибыль на конец текущего
output
года,
element is
а
the end of the
входными
year
элементами
profits, and
финансовые
input
инструменты,
elements,
которые
financial
влияют на
instruments that
данную прибыль.
influence this profit.
И, соответственно, немножко о
And
самом
a little bit
предприятии.
about the enterprise
Крупное
itself.
предприятие, для него
Large
собирались
enterprise, for
данные
it,
из
we collected
общедоступных
data
источников,
from
данные
commonly
все были
accessed
пронормированы и
networks.
приведены к единой шкале
We
XDR.
normalized
И само
data.
предприятие, оно является
The
монопольной
enterprise
государственной
is
корпорацией.
monopoly state
В ней
corporation.
присутствует 300
It has
предприятий
300
дочерних,
enterprises,
которые
subsidiaries
находятся либо
that are located
как
either
в полной собственности,
in
либо
full
как
ownership
акционерное общество
or as the
представлены.
corporations.
И вот на схеме,
On the scheme,
на диаграмме
on the
представлена
diagram, we see
схематично
schematic
модель
representation
задачи.
of the model of the problem.
Соответственно,
So
первый уровень – прибыль
the first level
корпорации,
of profit of the
второй уровень –
corporation, second
инструменты,
level
субсидии,
instruments,
займы, эмиссии,
subsidies,
те, которые могут влиять
lending,
на прибыль корпорации. Третий
emissions,
уровень – это,
third
соответственно,
level, if
организационные формы собственности, как я уже
organizational
сказала,
form of
они могут быть
ownership, as I said,
акционерными
can be
компаниями,
shareholders
входящие
corporation
в госхолдинг
that are
Росатом.
part of the
Они могут
state holding
представлены как
Rosatom. They can be
ФГУП,
represented as
федеральные государственные
TJUP,
управляющие
federal
компании,
state
ГК, то есть представлены
companies and the state
федеральными формами
companies
собственности.
presented by the federal
И,
ownership
соответственно, мы должны
status.
определить
So we
степень
need to
влияния
determine level of
финансовых
influence
инструментов
of the
на
financial
прибыль.
instruments
Что же
on
на самом деле
profit.
формирует прибыль предприятия?
What does form the profit of the enterprise?
То есть задача заключается в
And the
следующем:
objective
вычислить
is
степень
this.
влияния
We should
на
determine
общую
the level of
экономическую
influence
эффективность
on the common
используемых
economic
финансовых
efficiency of the
инструментов
used financial
и их
instruments
групп при помощи анализа
and the
нейронной
groups
сети.
through the analysis of the
И
neural
на
network.
слайде представлена
On the
модель
slide we
нейронной
see
сети.
model of neural network.
Соответственно, вот она иерархическая.
It's hierarchical.
Это это нейрон.
It's
нейрон второго уровня,
second level
нейроны
neuron,
третьего
neurons
уровня,
of
нейроны
third
четвертого
level,
уровня.
neurons of the fourth level.
Внутри нейрона это,
Inside of neuron
соответственно, функция активации
is
нейрона.
function of
Мы
activation of neuron.
использовали
We used
гиперболический тангенс. И,
hyperbolic
соответственно, после того,
tangents.
как
And
описана
after we
нейронная
describe
модель,
neural
мы
network,
формализуем данную
we
модель.
formalize this model,
на слайде
and it's
формула,
presented on the slide
которая
on the
вычисляет
right.
эффективность. Эффективность это
Formula.
как раз это
Efficiency is E,
нейронной сети,
is the
которая
output of neural
выражается в виде
network
прибыли текущего
expressed in
года
the profit of the
этой
current year
корпорации.
inside of the
И,
corporation.
соответственно,
And
вот эта модель в
this
качестве
model,
критерия
as the
оптимизации
criterion
был
of
выбран
optimization
обобщенный
was selected,
показатель.
general indicator
Это совокупная ошибка
is
нейронной
the
сети.
consolidated error of the neural
И
network.
при оптимизации
And during
совокупной ошибки
optimization of
нейронной
the
сети, она,
consolidated
соответственно, должна
error of the
к
network
минимуму стремиться.
should
Мы
approximate
получим
minimum.
обученную нейронную
We'll have
сеть с
taught
подобранными
neural network
коэффициентами,
with selected coefficients,
коэффициенты, которые в этой сети будут распределены
which will be
соответственно
distributed
степени
in
влияния
accordance with the
факторов
levels
и
of
их групп
influence
на
of the
конечную
factors and groups
экономическую
at the final
эффективность.
economic efficiency.
И на данном слайде
At given
представлены,
slide, we see
соответственно, данные
as follows: data
по всем
on
показателям,
all indicators
которые были собраны из открытых источников.
collected
Эти
from the
все
open
данные
sources. All
приведены
this
к
data
нормируемой шкале
normalized to the scale
XDR.
XDR,
И, соответственно, эти данные,
and this
данные
data
по всем
on
финансовым
all
инструментам,
financial instruments,
они
they
нужны для того, чтобы
are necessary
модели, они были отражены.
in the model,
И после того, как
and after
мы модель построили,
we
посчитали,
build a model,
вот
we
наш результат
calculated,
нашей модели, мы
result of
видим,
our
она
model calculation.
ошибка сети
The
достаточно
network of the
небольшая, так
network
скажем,
is
результат
quite
получился
minuscule,
неплохим.
result is quite nice,
И сами коэффициенты,
and the
представленные на
coefficients
слайде,
presented on the slide,
они интерпретированы,
they are interpreted,
и можно увидеть
and we can
долю
see
влияния,
the share of influence,
какой инструмент оказывает какую долю
what
влияния на
instrument
результирующий
has
показатель, на
certain
прибыль
share of the
корпорации.
impact on the
И мы
profit of
видим, что
corporation. And
субсидии
we see
в
that
данном
subsidies,
случае вот
in this case,
93%,
93%,
с такой степенью, с высокой
with
степенью
certain
вероятности
degree of
влияет на
probability
прибыль
impacts the
корпорации.
profit of
Эмиссии
corporation.
меньше,
Emission is less,
эмиссии меньше, кредиты,
emission is
займы
less,
практически не
loans,
влияют на прибыль
and
корпорации.
the credits
Модель
are
построена
less
таким образом,
influential.
что она
The
является
model is done like
динамической.
this, that its
То
model
есть мы можем
is dynamic.
рассчитать
We
и
can
за
calculate
2017 год получить
for the
по
17th
степени влияния
year in
финансовых
terms of
показателей на
degree of
результирующий
financial
показатель.
indicator,
И за 2018 год
and
посчитать
for
степень влияния
2018 we can
на
calculate
результирующий
degree of
показатель.
influence on the
2019 года нет,
final result. We don't
поскольку
have 19th
исследование заканчивалось
because
2019
research
годом, и
finished in
информация
19th,
последняя была за
and
2018
last
год.
information was for the 2018.
Следует отметить,
We
что
should note
вот сама корпорация
that
была
the
взята,
corporation itself was
как бы скажем, можно сказать,
used, as one may say,
случайным образом. На самом деле данная
randomly.
модель,
This model
может быть, она,
may
как бы
be
скажем, гибкая, и она может
is
быть
flexible,
применена
can be
для
applied
любого
for
предприятия,
any
которое
enterprise
имеет своей
that
целью,
has the purpose,
например,
for
максимизация
instance,
прибыли.
to
То есть у
maximize
него
profit.
есть
It has
входные значения, есть
input
выходные
data, there's
параметры,
output
и эти
parameters,
параметры выражены
these parameters
количественно.
expressed in
Если в
numbers.
предприятии эти параметры
If
выражены
enterprise
количественно, то к
expressed
ним
in
можно
numbers,
применить
then
данную
we can
модель,
apply given
которая
model
построена на
that
сверточной
is
нейронной
based on
сети.
the neural
И,
network,
в принципе,
and in
результат этой
principle,
модели
results of this model
достаточно неплохой.
are quite nice.
То есть нейронная сеть
The
решает
neural
задачу,
network
здесь
solves
показано,
the
что нейронная
problem as it is
сеть
shown
решает
here.
задачу
Neural network solves the
классификации,
problem of
но
classification
и справляется со своей задачей.
and handles the
И
problem.
реализовано это в Excel.
It is realized in Excel.
И, на этом мой
Hereby,
доклад
my
подошел к
presentation
концу.
comes to the end.
Спасибо.
Thank you. Thank you, Vera Alexeyevna. Very interesting presentation. Tell us, please, how many layers in your network?
4.
4. How do you determine layers? There's link between physical parameters.
С физическими обязательно. Это
Definitely.
мы подаем на вход реальные
We
значения.
send to the
Естественно,
input
все
real
значения
numbers.
пронормированы, и все
They're
значения,
normalized.
они,
And all values are
они собраны,
they
они
are
очищены от
assembled. They are
инфляции.
filtered from inflation.
Это реальная статистика по
These are real
предприятию за
statistics on enterprise for
2007-2018 год. Эти
2007-2018.
данные подаются на вход нейронной
This
сети.
data comes to the input of the neural network. Tell us, please, did you reconcile the data, what you have at the output of classificator, with the data that you send to the input? The reality check.
Только как сумма квадратов
As the sum
отклонений.
of the
То есть
squares
только как
of the
мы минимизировали
deviations.
ошибку сети.
So we
Наша задача
minimize the
была
error of the
получить
network. Our objective was to gain
результат.
results.
Вот этот вот.
So it's classificator, yes, we can see. You see the level of
Степень, да,
influence.
подобрать, то есть нейронная сеть работала как аналитический инструмент, подбирала коэффициенты, то есть степени влияния на выходной результат, в зависимости от истории, на исторических данных за период 12 лет. То есть достаточно было. Почему нейронная сеть здесь использовалась? Потому что достаточно было 12, вот 3, 6, 9, 12 точек, 12 значений. Выборка состояла всего лишь из 12 значений, и результат получился достаточно значимым. То есть именно нейронная сеть могла бы справиться, не любая другая, например, статистическая модель не смогла бы справиться, поскольку выборка слишком мала, меньше 30 значений. Она бы показала не...
It would show. Thank you. How did you teach? How did you compose data set for the model of the neural network? Did you develop data set or you did it directly?
Но датасет — это входные значения,
Data set is
которые
input
в модель.
data. So you went to
Нет, датасет
classification.
все вручную. Датасет
Everything was
собиралось
done. Data set
вручную.
was done manually. Did you have enough data? Because you had to use other data, or not those that you mentioned at first. Not those. You taught not using data that you sent to the input of the network. You want to say cross-validation. I'm saying about cross-validation and reliability because teach with one array of data and reconcile with the other set of data.
Речь шла немножко,
It was
больше об аналитической модели.
About analytical model,
Здесь
let's say.
не было вот как
There was no
проверки.
reconciliation. How much time did you do it?
Но в течение сама работа заняла около 6 месяцев. Сбор данных.
Data collection. Data collection is the lion's share of work. 90% of work is collection of data and processing data. All right, good. Thank you. Any more questions? Yes. Please come back to the network graph. All right, the previous slide. Is this graphical representation? Is there any sense that neuron of upper network connects to the two neurons of the next level?
Это иерархическая сеть.
Yes, it's hierarchical network.
Это чисто иерархическая
сеть. It's purely hierarchical network.
Это не граф.
It's not a simple graph.
Нейрон первого уровня связан только с нейроном второго уровня, а нейроны второго уровня только так, как показано, так она и работает.
No, I mean the left neuron after main neuron connects only with two. As for the others, it's not connected.
Вот этот вот?
This one, a neural network, every node connects to the other.
Это архитектура не с каждым. Это архитектура именно под конкретную задачу. Было бы у нас другое предприятие, была бы у нас другая система. Это нейронная сеть именно для конкретной вот этой архитектуры.
Fully connected network, you mean? It has different configuration. So it doesn't use the other rule. It's like additive wrap. So it's different architecture. Yes, thank you. Vera Alexeyevna, how much time you spent by launching into working mode after collection of data?
Минута две, все очень быстро.
About 2 minutes, it works very quickly.
В Excel посчиталось просто быстро.
Very swiftly.
Ну и, соответственно, я могу Excel-модели, если будут интересы, безусловно, я могу заинтересованным преподавателям, слушателям, безусловно, все это открыто и вот, представить и показать. То есть это задача достаточно простая.
Quite simple problem.
Нет, Excel, инструмент Excel. Только Excel, только формулы, и даже макросы не использовала, и даже Visual Basic не использовала, только формулы. Да. Поиск решения, только поиск решения, эволюционный поиск, есть в Excel прекрасный инструмент, там поиск решений, и есть метод эволюционного поиска, метод обобщенного приведенного градиента, и он прекрасно решает задачи подобного типа. Да, спасибо, и координаты вот представлены.
Thank you. Any more questions? If there's no more questions, allow me to ask. At 4:30, we're supposed to have break. So should we make break or listen to the next speaker? Yulia Alexandrovich, at 16:40 we need to have a break. Should we make break now? Yulia Alexandrovich, can you hear me? What shall we do? I would go for break. We have two Alexanders. Is the same Alexander or it's two different people? Who is simply Alexander? Can you hear me? I tried to enter 2 times. Alexander Ivanovich, it's you. Yes, it's me. It's Bogomolov Alexander. Let me rename you. Good. So we can listen to Alexander Ivanovich.
По расписанию мы должны перерыв делать.
According to the schedule, we need to have break. Alexander Ivanovich, how's your time? Can you make it after break? You'll be first after the break. We tried to invite you. It didn't work out. All right, thank you. After the break, you will be the first one. Colleagues, thank you very much for participation in this session. After the break, we can come back. Володь, а сколько на часах? И у меня 15:37. Так она толком и не сказала, сколько перерыв. Ну что, отключай микрофон.
Алло, меня слышно?
Слышно?
Слышно.
Ну, отлично. Спасибо.
Юрий Александрович, слышите, да?
Да.
Юрий Александрович, там у нас сколько докладов осталось, включая вот доклад ваш головиной?
Насколько я знаю, всего в итоге 3 доклада.
3 доклада осталось. Значит, сначала Александр Иванович делает, потом, наверное, кто следующий будет?
Пускай Михаил Владимирович.
Ну хорошо. И потом вы, да, последний?
Потом я выступлю еще раз.
Хорошо. Я для администратора хочу рассказать. У меня просто очень сильный шум с улицы, поэтому я то включаю, то выключаю видео и звук. Это именно потому, что там идут работы, и чтобы не мешало докладчикам.
Да, хорошо, но видео-то можно не выключать.
Видео можно не выключать, и зачем вам мое видео? Я включаю, когда я говорю, когда я докладываю.
Эффект присутствия.
Эффект присутствия, он есть, ощущается в моих вопросах. И поэтому я, когда удобно, включаю видео и звук, когда только звук, поэтому секцией все равно руковожу.
Я прошу прощения, у нас тут возникла проблема. У нас 2 Александра Ивановича Богомолова.
Да?
Да.
Ну, тогда
говорит только
по программе какой доклад вот у Александра Богомоловича первого?
Он, наверное, зашел с нескольких устройств.
Может такой быть, да. У меня один только доклад Александра Ивановича Богомолова.
Нет, доклад-то один, но в участниках 2 Александра Ивановича, но вот, один не отвечал.
С Невежиным Виктором Павловичем у меня его так
Может быть, мне, прошу прощения, может быть, мне выйти, а потом,
нет, вот вы
потом снова зайти?
Нет, оставить.
Я могу просто закрыть ту страницу, с которой вы не сидите. С которой вы
Хорошо, это было бы неплохо.
Секунду.
Коллеги, а есть еще Александр Иванович Богомолов?
Я здесь, если меня слышно.
Да, ну это вот, Александр Иванович, это вы, который вот с Виктором Павловичем, правильно?
Да, совершенно верно.
Так что он один у нас. И он сейчас будет делать доклад.
Да, все, я убрала второго.
Пожалуйста.
Спасибо, и стало лучше слышно. А то у меня тоже было какое-то эхо и наложение звука.
Пожалуйста, Александр Иванович, ждем вас.
Хорошо, сейчас я открою экран. Так, вы не можете включить демонстрацию экрана, поскольку демонстрация экрана организм просил включить.
Щелкните еще раз, я еще уже выключил, щелкните еще раз.
Так, хорошо, еще раз, да? Окей. Так, и демонстрация экрана, да? Так. Угу. Хорошо. Развернуть, наверное, во всю эту самую, во весь экран.
Пока слайдов.
Пока слайды, да. И сначала, да. Ну вот, доклад называется... Да.
So the title of my good afternoon once again, dear colleagues. So building a econometric model on the basis of harmonization with sound form. I will start by saying that the applied science in the future can be regarded as a fundamental science because it's trying to resolve 2 fundamental problems: to understand the causality of events and to look into the future. And if we do these problems, then these problems are fundamental because we can reach the ultimate reason, or if we look into the long future, to the physical essence of time. That is why this science is very interesting, and it could be very useful for the students, but for the time being, as we can see, over the last 50 years, nothing principal new in the econometrics and in the models that we teach students, nothing is changing. So this theorem of Gauss-Mark, which is the nucleus of our econometrics that we teach, those tests, Darby notes, Goldman and others, which takes most time and presents biggest problems for students. It should be discarded a long time ago, and the discussion of such paradigms of econometrics on which it should be based, they're not very many, though some experts and scientists are doing that. And for a long time already, big scientists put econometrics into criticism, but nothing has changed. And here, what a fundamental science is a system of sciences about the properties of objective reality, which doesn't have practical application. But in this case, econometrics could be considered 100% an applied science, but nevertheless, it should be based on some in-depth senses of the objective reality. And to this in-depth senses of the objective reality, I would, among them, name the uncertainty of our world, freedom of will given by God. And this is a result, and all the processes in the world, including in the quantum and microparticle world, they have uncertainty, principled uncertainty. Also, to the fundamental, the major role of information and time. I won't speak about the relation between the information and time. It's a separate topic for discussion, but nevertheless, possibly that information, along with time, is a fundamental attribute which appeared at the very beginning of our universe. And the role of information is ever growing, and we're living in an information society, all of us. And nevertheless, in our discipline, econometrics, it doesn't have any reflection. And another fundamental property of our world is the vacillation processes, which are in the basis of all the events of our world. For example, any microparticle or macro body is characterized by a wave, by frequency of vacillation, and microparticles can be presented as a wave, and electron has corpuscular and wave functions. And the string theory about the which explains how, along with the Big Bang theory, it says that all our blocks, elementary particles, they are just strings with certain frequency of vacillation, and it's related to energy and then to mass. I think these oscillatory processes are a fundamental property which could be included into our econometrics. And apart from that, I think the transfer of energies between the interacting processes is well studied, and the resonance is the most efficient way of interrelation and cooperation. And I think it would make sense to pay more attention to this, including economic phenomena. That is why I propose as an approach to look into the possibility of providing econometric models. Let's take a linear model, very simple linear model, with the use of vacillation processes, oscillation processes. You know that any discrete curve could be split into Fourier row, an endless row of harmonicas with a given precision could be presented this discrete dependence or in unbroken dependence, like Fourier row could be split down into its whole number of, if we think that candidates into the explanatory variables can also participate in impacting the variables, then these candidates, if each of them is a sample, could be presented as a splitting down into a row with its own frequencies. If we try to build the amplitude frequency characteristic of a variable, and if we build a frequency characteristic of the oscillation processes, we will have, roughly speaking, two characteristics, amplitude and frequency characteristics. And if we set a task to assess the parameters, then we, even by modeling method, to choose the parameters that would provide for the best collision of, it means the best approximation of our model to y real. This approach would allow to avoid, I would say, a child's requirements for the linearity of model on the basis of which limits are given in the Gauss-Mark theorem and tests are made. And the next step, if we look into the changes of some explainable variables, like frequency wave processes, we can even transform some of those vacillation into the sound form. It is possible that that would allow us in the future to use the sound channel to get new knowledge from the same, about the same processes, like in economics and financial sphere. And if we have a chance, for example, to measure the uninterrupted characteristics, the continuous characteristic of the value that is characterized by the value of some financial asset, then in principle we can follow that or determine that with the help of transforming those vacillations into the sound form. And it would be convenient to have the transformation because with the wavelet transformation, we'll be able to explain when new harmonicas appeared that changed the situation from the balanced one to a situation when a real-time decision should be taken. That is why to look into a number of transformation may be more promising than splitting into the Fourier row. We should say that the studying of the sound channel and the using it in all kinds of spheres is gradually getting momentum. And an example is the work done by NASA when they looked into how different space objects sound, and the sounds of the space objects can be found on the internet, among other things. I think that the sound of space objects or the study of them is not just for fun. It's maybe also a source of some additional knowledge about those studied objects. That is why the sound channel is, it would make sense to use it in the economics to describe the dynamics of some economic processes. And if we formulate the results and the conclusions that we've come to, it could be done as follows: a method of select an optimal set of frequency characteristics model by DPF sample, and if we use the linear model of multiple regression, then knowing the amplitude and frequency function, we can set the task of choosing the parameters of model so that the maximum proximity between the amplitude frequency characteristics and explainable variable and the totality of explaining variable, transforming the range of frequencies in the sound, will be able to compare the amplitude frequency function, and we'll be able to add new substantive variables or exclude non-substantive variables. And I would like you to give you some sound, but unfortunately I wasn't able to do that. So thank you for your attention. So it was not rather a presentation, but rather a declaration, just to draw your attention to the fundamental problem of the discipline that we're teaching our students. Oh, that's all. Thank you for your attention. Alexander, can you in short not describe, but to tell us how the sound of one economic rows of data is different from another row of data? How from the sound you can guess what's happening there? Yeah, if we're listening to the sound that we have transformed from the spectrum of the Gazprom shares, then we can overlap it with some additional harmonicas that will give him some pleasant sound, because this sound will be more resembling some clicks or gnashing of teeth. We can transform it with filters into a nice sound. And if we need to permanently monitor online, not to miss the changes in the dynamics of that financial instrument, then to look permanently at the screen is pretty hard, or just to ring the bell. Maybe it's not very ergonomical, but if we are able by the ear, if an operator by the ear catches that something has happened, then the sound of the Gazprom shares changed radically. He can take a decision to diagnose this change with the help of some smart program of neural networks or artificial intelligence. So the sound channel, I think, will be used, well, to a lesser degree than the visual channel, certainly, than our vision, but we should not underestimate it either. I think that by managing complicated systems like common aircraft or a reactor, the sound channel may be used or maybe already used and plays some role. And then who knows that if we ask a question, why we should look into the sounds of stars, and why does NASA do it? Maybe somebody needs it. As Saint-Exupéry said. And I think that to look into the sounds of the models of an economic system and objects, I think in due time it can also become useful. And so this kind of approach can be useful. It's not a proposal to replace something with something, but at least if we use the parameters, the model parameters, the selection of the, and using the characteristics of the amplitude and frequency, It's quite a permissible approach, quite a possible approach, and we're getting rid of some non-serious assumptions that the processes are linear, that it's important to look into limitation of the Gauss theorem, because we should proceed from the goal if the goal is achieved, and if there is guarantee, and if we are sure that we have received what we wanted to know, with more or less permissible error. This is the main thing. And also what is studied by econometrics and forecast that is made based on the historical data with the assumption that nothing changes in the world over the time when the sample was collected. This is a very rough assumption. And this kind of wave approach allows to a degree look further into the future, because the waves they go not only into the past but into the future. Maybe I used too many words. Okay, thank you. Colleagues, any more questions to Alexander? Thank you. Very good presentation. Alexander makes fundamental presentation. There is something to think about, and the forecasting in the future is very topical, and this method will be. Thank you very much, Alexander. Thank you. The next presentation, if there aren't any questions, certainly.
Юрий Alexander, should we invite them? Овсяников Mikhail Vladimirovich. Yes, we'll listen to Mikhail Vladimirovich. Mikhail Vladimirovich, can you hear us? Are you ready to speak?
Это моя...
Да.
Алло, меня слышно?
Да, сейчас мы
Can
вас...
you hear me? Yes, we can hear you. This is my presentation. I'm ready to speak. Please make demonstration of the screen. Select screen. Can you see me?
Видно.
Yes, we can see you.
Надеюсь, сейчас видно, да?
Все видно, да.
Yes, we can see you. All right. And you can hear me. Now, I'm here. I'm slightly in a different environment. It's technical environment. But I think our research can be interesting as the information model. Now, topic of my presentation today, formal ontology of the life cycle of products. It is all known to you, the digitalization of economy, Industry 4.0. That's why the quality of the modern economy is digitalization. One of the points of digitalization is the digital twins and exchange of data on production and economic systems. I would like to tell you about our approach to this issue. This problem started not now. For decades, this problem was sort of occupying substantial area in developments and the systems that are really being created. 30 years ago, we had the concept that is called CALS technology of the life cycle of products. Key idea is factually considered the life cycle of the product made from states from marketing till recycling through design, production, operation, maintenance, realization, and the set of technologies of management of these processes. One of these interesting technologies is management of configuration, data management, and process management realizing these technologies, we have many interesting problems. Even more so, problem of solving these problems necessary to exchange information between different systems of enterprises, organizations, and so on. That's why one of the main goals of this concept is creation of models which provide interoperability of data. Factually, for data to provide integration of systems, an opportunity to interact between themselves, and if possible, to have additional tuning. This problem was dedicated to a number of research and can select three main directions. Theoretical research of ontology of enterprises, standards, presentation, and data exchange, practical solutions, and applied systems that didn't look at science, they did what was necessary to provide technical, technological, and other processes. If you look at the first direction, in this direction, in the Western world and in Russia, we achieved a number of results. On the slide, you can see key projects that have place here. Canadian, American, European projects, domestic project. The most interesting research was dedicated to the modeling of enterprises of modern Russia that was produced by the School of Economics. Key problem that was solved here, we can see that ontologies, and it was shown in order to build object ontology of concrete applied problems, we need to build ontology at the 4 levels. Meta-ontology, ontology of the upper level, ontology applications, and ontology of subject area, ontology of problems. If you look at the standards that were considered in CALS standards, in 90s till now, we will see quite a number of the standards of data presentations, many of which can be called standard ISO 10303, that was called in English STEP. The key idea was to create a model of data on enterprises that would allow to describe all data of enterprises from technology to the applied practice into uniform single one. Attempt of this was not successful, so uniform model didn't work out. There was integration of model, there was a language of description, and there was set of integrated resources, out of which we had applied protocols. Unfortunately, the applied protocols was 100, and between themselves they could interact. It was necessary to use separate interface to translate from one protocol to another. That was a good idea, but it was not realized. The key idea was in my opinion, key problem was a failure of this project, that was the accepted object-oriented model, whereby all information on the object is used at the object level, that's a set of attributes. There's opportunity to inherit, integrate. As for inheritage, create set of attributes. So this is inheritage. Such approach gave birth to every object having unlimited number of the proprietary attributes. Attributes of objects didn't connect inside themselves, so it was unlimited growth of such system. Information model. For one transition from one applied protocol to another, it was necessary to have specially developed interface. Although in the last times there was development of new standard, relatively new standard that considered slightly different model. However, we didn't achieve a system having data between them. They could be sent without transformation according to special interface. At the same time, a number of applied systems were made that use this approach, in particular system of data management. That was PLM. That had solutions that were realized later. Goal of our research: to build such information model which would allow to join data about the product so it can be used for different objectives at different stages of the life cycle of the system, which would have minimal source, presentation, and concept. And on the basis of this source concepts and states, we could use the model for solving concrete problems. This ontology should be clear. Just a second. I have a problem on my screen. It was on one side. We should say that the problem and the ontology was interpreted in different aspects. This concept is 1,000 years, and it came from philosophy. But we are rather interested not in philosophy for ontology as the model of the world, but ontology as a form of presentation of information model, which contains a set of concepts interconnected between themselves and strictly structured. Classical definition: ontology is structuring of the system of concepts. We're interested in precisely this model, where every next concept is formed from the previous one. And even in this aspect, there are different approaches to building ontology. On one side, ontology is used for presentation of natural languages, for description and classification of the concepts. We have slightly informal ontology that contains links, relationships that are formed in the process of research of data in concrete area. We're interested in slightly different approach. We're interested in model that could clearly form set of structures, and the concept can be used for application of algorithms, quite general algorithms, universal algorithms based on the heuristic methods would allow to solve our problems. We need ontology and model that would have minimal, would contain declarative processes that would allow to apply algorithms of artificial intellect. Formal ontology model can be presented as the three systems: multitude of the concepts, multitude of relationships, and finite multitude of interpretations. In such a way, as I said, elements of meta-ontology as concepts, relationships, samples of the concept's interpretation. Key questions for building meta-ontology. In order to build it, it's selection of model of ontology and determine minimum necessary and sufficient multitude of the concepts on the basis of which you can describe all the other concepts. At the same time, when we talk about concrete objectives that we want to solve, in principle, methods that we apply, they're based on the three principal classes. Methods based on rules. Example is production rule. Methods based on precedents. Case-based, we have solutions, and we look for the nearest solution. Methods based on models, model-based. And this method we want to use next. We're talking about selection of ontology model. There are three approaches to the ontology models. First, ontology of objects. We can see classical object-oriented model. We have objects related to the set of relevant categories. Second variant, so-called ontology of attributes. We have object doesn't have not a single attribute except for its name. And the attributes is standalone concept. And every object can be related to the free set of properties through relationships. In this sense, we set the value of this attribute. The most general approach, ontology of facts or situations. We don't have just one-time object related to property, but it connects to the situation. For instance, measurement of some size of some product in this particular moment of time by a concrete man through the concrete device. It gets this attribute. This attribute, unlike previous variant, doesn't have just one relation to the object. It can be unlimited number of the links describing situation, and this value has the context of given attributes of given object and set of additional relationships. That's why we try to go through the difficult path, but for our objective is quite enough to look at ontology of attributes, to have objects which don't have attributes. And in our system, our ontology will have the following concepts. The concepts: class, sample, situation, attribute, scale, and relationship. And types of relationships that can be in our ontology: object-object, part and whole, object, attributes, value, and relationship, attribute, value, key classes of objects. Its meta-ontology is fully limited. There is nothing in meta-ontology. Next will be ontology of the upper level and applied ontology. Based on these concepts, we can build any informational model or ontology of applied. Plus, to this, as interpretation, we use special language of description of mathematical relationships. We use a language of description that was made an ISO step. As the result of these ideas, we created ontology, of which is base concept, and we built system of concepts. As the basis for building such ontology, we used first AVL and ontology of the standard, as I said, 15956. For solving the problem of such ontology, at our chair we created a packet of programs, package we called solver of the problems. It's based on ontological model, it realizes algorithms of search of solutions. The solver transforms our mathematical expression into a syntaxis tree, and with it solves the problem. So the operation of such solver is it generates some solution and checks all dependencies that are described in this particular problem. Interesting, and yes, I forgot to say, this solver mostly uses method of satisfaction of limitations that allow us to solve every problem in 2 steps. At first step, it searches the escape way from the space of solution where all limitations are being observed. When it finds the exit way, it starts working as a separate function. well-functioning methods of evolutionary research and methods of heuristic search that can be realized at this point of time. We tried our system with 3 problems. First, synthesis of configurations of problem. We took automobile. Management of the repair of equipment and building of the schedule. With the help of our ontology, we have 2 reference books, reference of component and reference book of properties, and the links of component or object with the property. Plus, we have ontology of problem, and there is a set of positions. In particular, configuration is for every position we have to select component where all limitations written in this ontology of problems were met. Plus, desirable is to have function of optimization. Presentation of this ontology in OVL, formulas of computation used for this problem solving, and this is what we have at the end. The system showed that such approach allows to efficiently solve the problem. The user can, without limits, use, dependent on requirements, he can get solutions. When we talk about automobiles, the key requirement was maximum speed and more at the bottom graph. We entered this parameter, less number of permissible configurations we had. And was is function of the cost of this automobile. It shows how different algorithms work with this set. At this time, we conduct additional research, goal of which is to build final meta-ontology that could be applied to sufficiently big number of the problems, configuration management, process management, building schedule, and so on. Next, to build ontology of the upper level, commonly accepted classificator. And finally, we developed more efficient methods of problem solving with our ontology and interfaces to the existing systems of decision making, data management in the technical systems. Thank you for your attention. This is my contact. Questions? That was quite heavy presentation. Thank you, Mikhail Vladimirovich. I think questions will be, colleagues. It's a broad presentation and usage of this approach. May I ask question? Yes, of course. Also wanted to ask question. That's why, if I may, please ask your question and ask my question later. First of all, thank you very much. A very interesting presentation. It impressed me a lot. And because of this, I have a proposal to you. Because I'm related to development of standards of application of artificial intellect in medicine, the medical products, medical technologies. The standards in the second medical university are being developed, but I'm concerned with the quality of the work with the standards. I believe that the level is very low and links with other standards in information systems, security, safety, even with the standards and the medical standards, the links are practically absent. Even say standard life cycle of medical products and usage for the artificial intellect. I have a proposal to you. Can you find time and maybe participate as the consulting expert in developing standards for application of the system of artificial intellect in medicine? Alexander Ivanovich, I have a mail at the end. Yes, I've written down. I'm waiting for your proposal. And here's an important point. talking about life cycle, especially for medicine, we have two interesting aspects. Maybe it sounds wild, but there's a concept of life cycle of human being. In principle, ontological approach would be the most ideal for application to describe function with the systems, with the living organisms, dependence and links between themselves. It would be the most logical approach. The problem is also that even now, there's no object-oriented approach. It's limited. And here, approach of the next level, approach to the model of binary relationships. It's more universal. It allows, we have to show, when I talk about that, we have two classificators of objects and properties. Mostly, there's products, processes. Sorry, in economics, humongous number of the classificators. All these are object classificators. But if you look at the classification of properties, the number of properties, several degrees less than objects. It would be more steady classificator that could be used in description of the same objects. Yes, you know, I in the past wrote an article, small article that is called Aging and Death of People from the standpoint of modern concept of noosphere. It uses informational approach, and information is considered as the life power that comes when it leaves, man finishes his life. If we would discuss something in this area, it would be very beneficial. Thank you.
Если больше нет вопросов,
Нет, там были еще вопросы, давайте ответим.
Any more questions? Mikhail, do you know the works Valery Tarasov? And yes, we work together. They participated in this work. I would like to say they have a very interesting experiment in the field of measurements, and she was supposed to make a presentation today. Do you think about the standards? The main work is in translation of ISO standards for AI into Russian. And our own standards are made that will have to be checked out later. Don't you think that you should be a very encyclopedical guy to take up new standards in an absolutely new sphere? Do you think there will be enough information, not only about this, to tackle ontology without fundamental basic information blocks? Yes, I agree, but ontology already exists, already has a set of standards like ISO 2000 is an attempt to build a standard of information model based on ontology. And they say it's the ontology of the life cycle of a product. The process is underway already. The question is different. There are tasks for which information basis is enough to build ontology, but there are processes with a lot of uncertainty. Does it make sense to use ontology there, or just to wait for knowledge? It's a double-way street. You'll be building ontology and you will accumulate knowledge. And in which form you will accumulate the knowledge? The most natural form is ontology, to calculate knowledge, to collect knowledge, specific fact or specific dependence. And the most convenient way is to describe it within such an ontological information model. So there is a need to have an expert, a guy with knowledge, who will take away the unreliable data so that we won't have wrong branches of ontology. Well, there's no such a thing as wrong ontology. All the branches exist and they have the right to exist. I mean, the closest to practice. You understand? We will create those branches and we will link a system of specific objects to them. And on those objects and their properties, we will build a dependence. And a part of the dependencies will be correct and others incorrect. And with the help of formal mathematical methods, we will check the correctness, the compatibility. So it's kind of research work aimed at accumulation knowledge. Yes, because if you're looking at an applied example, you have specific information, reliable knowledge, but here you propose some research stage where everything is being improved and brought to a level. I propose each model in each sphere to be tried to be built on based on some basic notions, so that a specific field could be combined with another one. So the dependencies in one field could be transferred, but in the research part, nobody's insured against mistakes. But if we speak about some serious applied tasks, then experts are needed naturally, yes, naturally, and this is a limitation. And as everyone knows, in a lot of fields, but we will try to build a model that could check out the knowledge not of a person, but of a, yes, it's a noble task, but when fine-tuning is underway, it will be the biggest question, not to establish the links, but for the person to know. And the report is extremely interesting. Thank you, Mikhail. Any more questions to Mikhail? Well, I have my email and I'm ready. So if you want, you can write, you can ask questions now, or just take the contact details. Yuri. Now we have Alexei Sergeyev, who is on the program. You will make a presentation now, or Alexei? Or let's listen to your presentation. I wanted to speak now. Okay, let me explain first why I took the floor again. According to the program, there was a presentation to be participated in by two researchers who do the same project as I do, but they're missing today, and that is why their report will be presented by me. So the idea behind the presentation is that we try to use the same method, which I spoke about before, to analyze rare social, historical, and political events, but immediately I will say this is just an idea. Can you see the screen? So I missed it.
Значит, идея в чем заключается?
So the idea is that if we look into social, historical, political events and we consider them as events happening under some inflows and outflows, so we have a certain bowl or vessel that could be filled and emptied. The input flow can be interpreted as a flow of negative events, and for social sphere, it could be lower living standards. For political processes, speeches by some politicians or passing some events, historical events, some conflicts, intolerance. This is a flow of negative impacts. At the same time, there is an inflow of positive impacts that lower the level of the negative impacts. For the social, could be some guarantees, support; for political, some promises or PR or some laws; for historical sphere, just diplomacy. When a lot of issues are resolved diplomatically, concessions are made also with culture, affecting the lessening of some contradictions, exchange of trade, etc. And with the proposed mechanism, which I talked about before, that if we model an event per se as a process of overfulfilling this vessel, we're saying that the vessel is tolerance, then it overfilled and some event was generated, and then we think that the vessel is empty. It has been emptied as a result of the event. This model of rare events under the impact of the flows that bring about the overfilling. And with the help of the previous method, we can try by a set of data, and there's a data and some effects of the events. We can restore the resulting function. We can, and FT, the difference between the inflow and outflow, and we'll try to restore the resulting flow. The problem is we won't be able to restore each component of this resulting flow, only the resulting flow as a whole. And also, we are no sociologists or politologists or historians. We are only data scientists, and maybe we are not very grounded in our happiness, and we are not replacing historians, politologists, sociologists, and maybe we will add our methods to their methods. Now about the effects from events. For social events, as an effect, we can take the unit as a fact of event. If social events have some characteristics like the number of protesters, we can give the number of protesters. For example, how many people took part in some rally. Then the result could be expressed as a victory or defeat, 1, 2, 3, or change the numbers. It could be 2, 1, 3, depending upon which sense we will build into. But we will build the sense that after the victory we will get calmer, and that is why the result is 1. And after a draw, we are a little bit nervous, a little bit calm. But in case of defeat, we are intolerant, we are unhappy, and the result could be assessed as 3. These figures are conventional. You can choose anyone. And for political events, I could formulate only the fact of the appearance of an event, like a draw, victory, or defeat. We can take Y for those variables. For historical events, we can find more materials of fact, the number of participants in some historical event. If there are some battles, the number of casualties. If aggression, then the area of conquered territory, and the result, victory, draw, or defeat, and some figures. Then giving a number of the Russian-Turkish war, we know the dates of this event. We'll look at the beginning of the first date. It will be the beginning of this event, the number of years, how long it lasted, the result, the outcome, and the very fact of its appearance. And we can build different kinds of graphs, and we will try using this method to restore the resulting flow based on the values of events that had taken place. And the results could be like that if we build a graph based on the result. And I will try to give an interpretation of this function. And the area under the ladder It's when the function of the area under the ladder, it's the value of the event itself, the integral of the function. And the line shows the restoration of the function under the integral. And if the event took place in 1768, it so happens that in the method it's supposed that the next event will take place when the bowl will be filled again, bowl of tolerance. And then this function that we are setting could be interpreted as a function of increasing the intolerance. Historians will be right to argue that actually, if we look through the chronology, through not chronology, but get more detailed historical information, there will be some diplomatic conflicts or cases that bring about the interference of third parties, because Russo-Turkish wars were not between Russia and Turkey only. There were other parties involved, and historians could be more precise in this question. But at this time, we built on the result: 1, defeat of Russia; 2, a draw; 3, as a Russian victory. But we can be based on the fact when all the events are assigned 1, then the graph will look as like that. And we can interpret it once again as the speed of increasing intolerance and until another conflict. In terms of the longevity, like if we interpret in this case, if the result is the longevity, then it's a function of the speed of intolerance, but expressed, linked with days. It's not easy to formulate that. That was a Russo-Turkish war. There are other events like colored revolutions, the year of beginning, the date of end, but some revolutions took place on the same year, like in Kyrgyzstan and Tunisia, the same year. But to make the graphs more adequate, we can try to join these two events into one. Now, whether it's judicial or not, you cannot be absolutely sure to bring together these two events, but we combine the longevity and the number of participants of both events, and we suppose that these rare discrete events take place under the impact of some flow of events. Like the flow of events is some mechanism of instigating colored revolution in other countries. This mechanism works, and from one event to another, it needs some time for the preparation. And once again, if we are based on the fact, in analyzing, we have such graphs, the only thing I draw your attention, we shouldn't give attention to the value of the function when it is below 0, because it doesn't have any physical sense. And we had, in this case, to smooth out, to improve our function, because it shouldn't have gotten below the 0. And then we can interpret this function as the speed of increasing the preparedness or preparation to another color revolution in another country. In terms of the longevity or duration, we will have such graphs, and here this value is non-zero, the average, but close to 0, because the speed is expressed in this case in shares of day or 2 days. It's linked to days, it's small values, and between them many years pass, like 2 years pass between them. The function doesn't have a lot of importance. And once again, this is a speed of preparation, but linked to days. And in terms of the number of participants, not a very good result we had. And we can say as an interpretation as a speed. And now number. or hiring or mobilizing these protesters, or the speed of them getting assembled, or indignation, dissatisfaction cultivated in people, urging them to take to streets. And as for now, it's all the data that we have been able to process. And once again, this is just general ideas for an analysis. Thank you. Any more questions? Not for the time being. Okay, we're at the beginning, and the task set is an interesting one, and we should wish you success because it's a part of your, yes, it's within one subject matter. Any more questions to Yuri? Maybe a proposal.
Topic, the theme is very relevant and interesting. Not many people do it, although it's very important, especially now, when we live in such uncertain world, when everything's become more complicated and variability becomes higher in all spheres of life. That's why it seems to me that's really relevant topic. It seems to me that rare event can be the consequence of the resonance, where a number of the reasons cause war or the color revolution. And what you drew, and if we distribute influence of this event, it reminds distribution of the dissipating wave. And the amplitude of this wave can dissipate at the end because of the additional other events that can drastically rise and create more important of the event. The example is Hatch's interpretation of the Second World War, of our victory, rewriting of the history, recent Armenian-Azeri conflict, both sides repeating the complaints, and the events go to the second place. So I'd like to suggest to consider this wave description. May I say, sorry, as far as I remember, when there was Orange Revolution, the witnesses said that people said the following: yes, we are minors, we have 300 hryvnias, and others have 800 hryvnias. We have to pay for this. Somebody has to pay for this. I'd like to say the oscillating process necessarily harmonic, not necessarily a wave. It can be complex, some complex combination of the impact, firstly, and secondly, the reason behind color revolution are many. You can say that director of the CIA said, and people raised for the color revolution. Revolution happens because position of people is worsening because of from retail cigarettes disappear. The weather is getting worse, and many other reasons can happen. Each reason separately cannot cause what we call random event, but the combination can be used. Really targeted events, applying the forced oscillation causes resonance. So it's not harmonic. Resolution of the equation can be different. If we use non-harmonic oscillation process on harmonics, the composition will have this very oscillating process that is harmonic. Absolutely correct. We're saying that in 70s or 80s, there was powerful movement, and show the example, not harmonic examples, even Fourier series that you used as an example in the frequency range. Thank you. Thank you very much, Yuri Alexandrovich. We worked Excellently. You made presentation. Very interesting. Questions to you, Alexandrovich. If you can privately answer the questions. Yuri Alexandrovich, can you answer in private order? We have Alexey Vячеславовich. If there is someone else, we don't see presenters. But for now, I see Alexey Vячеславовich Sergeyev. That goes according to the list. Alexey Sergeyevich, are you ready for presentation? Can you hear us? Yes, I can hear you. You're welcome. Open your presentation. We're waiting for your speech. As far as I understand, it's the last presentation. I don't see anything else in our session.
Видно мою презентацию?
Видно.
Can you see my presentation? Yes, we can see.
Хорошо. Добрый день, уважаемые коллеги.
Good afternoon, dear colleagues. My name is Sergey Alexeyevich Slavchev, and I would like to make presentation about modern methods of modeling of the structure of investment portfolio. At first, I'd like to say that it's true that modern tendencies, they position us that financial markets become more and more desperate, and more participants, more people, and their interests with the purpose of gaining profit or saving of capital. Because of this, I'd like to consider methods that are being applied, and I'd like to start by saying that I'd like to emphasize that based on classical methods of mathematics, they help us. They're a basis for modern financial calculations. And here, we should make a commentary that classical methods, of course, mostly consider determined models of financial operations, whereby we have presence of full certainty of time financial indicators. At the same time, these methods, as many people know, help to establish principal schemes of operation of different financial assets and consider in the calculation such parameters as the time rule, as I saw on the slide, the characteristic of the flow of payments, interest rates, margin, period of transaction, the scheme of the occurrence of interest rate used by the participant of the operation. Taxes, including taxes also, we can calculate with the help of classical methods, considering also parameters such as position of investor, it occupies long, short position, and so on. At the same time, coming to more realistic situation, we should take into consideration a fact that market has quality, it's stochastic behavior that entails necessity to use slightly different methods which are necessary for decision making, and decisions in the real situations. It works out when investor needs to make decision
значительной степени неопределенности
in the very uncertain situation and proprietary risk. A little bit coming to the next point, we realize that ideal assets in the market don't exist. The assets that would have maximum profitability with minimum risk. If they were to exist, it happens that all participants would try to take advantage of the situation and operate with them, and they would change the indicators. So investors are interested to smoothen out position with risks and thus apply some methods, that is, in particular, to diversify the risks, as the rule can apply to build investment portfolio. It happens that degree of diversification of portfolio composed out of the assets depends on profitability for each particular asset, and also on degree of interrelations of the assets, of so-called covariation of assets. Any portfolio can be represented as the set of parameters, such as vector of expected profitability of the assets. And hence, of course, the key interest is that while building investment portfolio, we need to find weight of every asset in order to collect necessary portfolio. There is a classical theories. One can mention Markowitz model, which supposes building of the optimal portfolio. Indeed, we can select three approaches, the key approaches: the search for portfolio with the maximum profitability with set amount of risk, to some degree reverse problem with a fixed amount of risk and the maximum profitability of portfolio, otherwise with consideration simultaneously of two indicators. And here we have the concept of function of utility and coefficient of non-acceptance of risk. Any investor can have different coefficient, but they manage to find portfolio based on two values: its risk and profitability. It's important to mention that Markowitz didn't suppose presence in portfolio of the assets would have negative profitability. That is, in other words, it didn't suppose for investor to have presence of the short position of portfolio. And here on the slide also show there is model of black based on the model of Markowitz. At the same time, the portfolio, not only assets for long positions, but also short positions. The next model is Tobin-Sharpe-Lintner, and also one may say relate to the previous mentioned model, but in this model, specific is that portfolio is being built with presence of the assets of so-called non-risk assets.
Соответственно, на основе...
So, based on the model Tobin-Sharpe-Lintner, or simply Tobin model, based, there is another model, KPM, Capital Asset Pricing Model, according to which
можно рассчитать оптимальный
we can calculate optimum portfolio for investor. And key resume from this model is that optimal will be portfolio that is composed out of the linear combinations of non-risk portion of portfolio and the risk portion of portfolio. And this is the list of classical methods. The key feature of this method is that they work directly with statistical data collected during a certain period of time with the selection. But movement of the market happens to be unpredictable. And here, these models don't consider risks which are present and that affect behavior of the market. So I listed risks, just a few words to explain: political, economical, linked to with the change of global change of political situation, perhaps change of priorities of the state, opening. Now it's less global, it's more adaptive. So maybe attention of the state towards new spheres and the opening of the national projects that can entail change of situation on the market for a certain group of assets or the sectors of industry. Market risks, risk of variation of the interest rate, also caused by the change of political economical situation. Currency risk has to do with the exchange rate of forex. Presented mostly by investment portfolio and so on. The key objective for me will be that to take a look at how listed risks, maybe to classify it and structure and include existing classical models in order to make understanding of those risks and measuring of this risk and data on them, they could be put in foundation of the forecast data can be used as the foundation for investment decision making. It's decision of investor to include some assets into investment portfolio. For now, thank you for your attention. Thank you for opportunity to speak. Thank you, Alexey Vячеславовich. Alexey Vячеславовich is the postgrad of our financial university. It's his first year. He's only starting to scientific research in the broad aspect. The work is very relevant, and he works in the area of banking activity, works on finances. Questions to him. I think that presentation happens. He should continue his work properly. Should involve systematization apparatus and use recommendations for forming portfolios based on classics. We can have good approach. Colleagues, questions? My question is, your specialty is number 13. Yes. In the future, you will have to demonstrate your model, and not just model, but show why it's better than preceding model. It will not be simple task, because this topic is rather popular. Not necessarily your model is better in general, but because investment can be with stocks, can be model not for the shares of stock. There are several ways. The model of efficient for in all senses or in concrete conditions. Otherwise, can be even switch from investments to something else, to something that other people didn't do yet. A lot of work is ahead of you. All right, thank you. Thank you, Yuliy Alexandrovich. Colleagues, any advices, colleagues, or commentaries? If not, you will be able to talk to Alexey Vitalyevich. We can use some approaches. Colleagues, thank you, Alexey. Looks like we finished presentations, and we briefly discuss discussions that shows the most interest. Specifics of this discussion is this: the colleagues that are present here, practically, they were not present with Yuliy Alexandrovich. He listened to the first presentation. So let's discuss the second. As for the first, you talk privately. Yuliy Alexandrovich, what's the algorithm? Yuliy Alexandrovich, can you hear us? He disconnected. I'm here. I had phone call to receive. I suggest to discuss presentations in the second half of the session, the most interesting with the colleagues. As for the first time, advise colleagues that were during first half and left, unfortunately. As you decide, we'll do. I need to answer the phone call. All right, you can do it. Let's do this. Question to this present people. What presentations of this part of the session, the segment, you would like to single out as successful, although all presentations were successful? Which one makes you remember for a long time. Should we put as candidate for the gratitude for the plenary session? We'll report the work of our session. If you have any proposals, I'm ready to listen. I don't even know. I liked all presentations. Every presentation has scientific value and practical value. It was great. I'd like to thank Yuri Alexandrovich. He made 3 very good presentations. The third was less developed than the first 2. That's why colleagues didn't hear. There were a lot of mathematics, many scientific ideas. So it was important for him to make this presentation. Thank you, Alexandrovich. Yes, I support. I also liked the idea of the work and presentation of Yuri Alexandrovich. And I liked Ovsyannikov. Meta-ontology was very interesting. Alexander Ivanovich had very interesting presentation. I think I'll not be wrong if I say that if I list all participants with characteristics and novelty, very short characteristics, so that all people present here know that such wonderful presentations were made at our session. So those names that were mentioned, there was good presentation by the colleague left. I forgot his last name. From Tula. Roman Alexandrovich Zhukov. He had very good presentation. Perhaps like this. Some group of presentations were noted as very successful. Colleagues, anyone willing to say something? Okay. I'd like to remind our group of technical support was very helpful. Thank you very much. Thank you, volunteers. They were here. And communication and hearing quality and visuality was very good. So thank you very much, colleagues, for wonderful work. Translation was very good. Everyone worked well. So congratulations. All the best. So we close the session. May I have a small question? Can we see this recording? It's the question for the organizers regarding the recording of the video and audio. I will give a link to all here in chat, the link to the conference. In the bottom of the conference, all links to the online translation in English and Russian. Yuri Alexandrovich, send it to all participants. I sent to the chat, the site of our conference. On the site, we have all links, all references to YouTube channel for all sessions. So you can open and see recording. And if you can hear, if you didn't hear for some reason. In this case, thank you very much. Thank you very much. A wonderful organization. It's wonderful. We should know that participants expressed their thanks. Thank you, colleagues. Good luck to you. Wish you good health and, of course, fruitful collaboration in the future. Thank you. All the best, colleagues. Goodbye.
Ну все, наверное, организатор трансляции может завершить запись.
Да. Спасибо,
Николай,
организаторам.
вы слышите нас?
Да, сейчас я выключаю.
Можете завершить.
Угу.
Спасибо, что все устроили.
Да, все было отлично, без всяких